the next chapter. The next chapter in statistics is correlation and regression. So correlation and regression, first we'll look into what correlation is. What is correlation? It's the relationship between two variables, the study of relationship between two variables, relationship or lack of it, association or lack of it between two variables is correlation. So in understanding correlation, before looking into the concept of correlation, we need to understand a different set of frequency distribution. Normally, when we are looking into a frequency distribution, we have only one variable, right? And the corresponding frequencies for that variable. Whereas for correlation, obviously, we want two variables to understand the relationship between those two variables. Hence, we go with bivariate frequency distribution. That is the frequency distribution of two variables simultaneously, right? Preparation of frequency distribution of two variables simultaneously is called bivariate frequency distribution. And so on the columnar side, we'll have one variable, and the rows, we have the other variable. And in the body, we have the corresponding frequencies of those variables. So here, this is bivariate distribution. If I consider the frequency distribution, a single frequency distribution of a particular variable from this, then that frequency distribution we call, I'll take, let's say, X and Y. From this, I'll prepare the frequency distribution of X with corresponding total frequencies of all the values of Y. This frequency distribution of X for all values of Y is called marginal distribution. It's called marginal distribution. Frequency distribution of one variable across other variables, full range of values. Similarly, frequency distribution of Y for all values of X, we call it marginal distribution. However, frequency distribution of X for a given value of Y, for a certain given value of Y, conditional value of Y, we call it conditional distribution. So we'll take an example. So marks in mathematics and statistics, 0 to 5, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. To 25. Okay. Now, if I obviously will have the total. Now, if I take out frequency distribution of statistics for all values of mathematics, 0 to 5, 5 to 10, 15 to 20, 22, 25, 25 to 30, then that is called
marginal distribution.
Marginal distribution. However, if I take out frequency distribution of statistics for marks scored in mathematics between 10 to 15 and 15 to 20, this is called yes, this is called conditional distribution. So if I consider the total column of the frequencies, then it is marginal. If I consider some of the class intervals or one of the class intervals, then that is conditional. That is conditional frequency distribution. So that is the difference between marginal distribution and conditional distribution. So this is about bivariate distribution. So why we had looked into bivariate? Because for correlation analysis, we want two variables. So we looked into bivariate distribution. Now, as we have discussed, correlation is analyzing the relationship between two variables, right? If there is a change in one variable for corresponding change in the other variable, then we say those two variables to be correlated, right? That change need not be in the same proportion. It need not be in the same direction. It could be in the other direction as well, in different proportion as well. So if the change of one variable results in change in the other variable in the same direction, then we call it
directly proportional. Positive
correlation. If it is in the same proportion, then yes, directly proportional, right? But then we call it perfect positive correlation. So positive correlation, two variables move in the same direction. Whereas if the change in one variable results in opposite change in the other variable, we call it negative correlation. Negative correlation. if the two variables are, we consider two variables to be uncorrelated if movement of one variable does not result in any change in the other variable, then that is uncorrelated. Now, with regard to correlation, yes, we can understand whether there is correlation or not, and to calculate what is the extent of relationship, what is the extent of correlation, we have different measures of correlation, right? Different measures of correlation. First one is scatter diagram. Scatter diagram, we are not calculating correlation, we are just identifying whether there is correlation or not. If there is correlation, whether there is positive or negative correlation, full stop. We are not getting the extent of correlation that is there. So this is diagrammatic representation, diagrammatic method to establish correlation. What are we doing? We are plotting all the values in the graph. Based on the patterns that arises in the graphical representation, we will determine whether there is a correlation or not, right? This here measure, we are only looking into identifying the relationship and not measurement. However, one of the advantage of scatter diagram, which is not there in the subsequent methods that we'll discuss, is this can be applied for linear as well as non-linear data. Whereas the next one, the Karl Pearson's product moment or the subsequent methods that we'll discuss can be applied only for linear. Whereas scatter diagram can be applied for non-linear as well. Scatter diagram can distinguish between different types of correlation, although it fails to measure the extent of relationship. The pattern reveals the nature of correlation. In case of positive correlation, the pattern would be from lower left to upper right. In case of negative, it is from upper left to lower right. This can be asked. Okay, so the plotted points are from lower left to upper right. What is the nature of correlation that we have? So it is positive. If it starts from upper to lower, then it is negative. Easy to remember. Rising means positive, falling means negative. Okay, in case of zero correlation, no pattern, it would be distributed in haphazard manner. There would not be any pattern among the pattern in that diagram that we have plotted. So this is scatter diagram. Next one is Karl Pearson's product moment correlation coefficient, one of the best method of correlation that we have, right? Why? Because it establishes relationship between two variables in a systematic manner, in a scientific manner. However, it can be used only in case of linear relationship. Now, how do we calculate correlation? It is the ratio of covariance of the two variables to the product of their standard deviation. So covariance of xy divided by standard deviation of x into standard deviation of y. Now, this can be further expanded. The formula can be expanded to summation x minus x bar into y minus x bar by n, or n summation xy minus summation x into summation y whole divided by root of n summation x square minus summation x the whole square into n summation y square minus summation y the whole square. Very important formula. The formula of Karl Pearson's correlation coefficient. This is for obviously ungrouped data. However, in case of a bivariate frequency distribution with grouped data, frequency distribution, we have to use frequencies as well. So in such cases, summation xy into f minus x bar into y bar whole divided by n, and standard deviation of x would be summation fx by n minus x bar the whole square. Standard deviation of y will be summation fy by n minus y bar the whole square. Again, obviously problems cannot be asked in the exam with regard to frequency data. Problems, in case if they ask, it would be ungrouped data only. What are the properties here? Properties of correlation coefficient. Under Karl Pearson's method, it is unit-free measure. Whatever we have calculated is free from units, and correlation coefficient always lie between -1 and +1. -1 is perfect negative, +1 is perfect positive correlation. Correlation coefficient, one of the important properties is it doesn't get affected by change of origin and change of scale. However, in case of change of scale, it might get affected with regard to the sign. It might get, not always. That depends on B and D, the respective scales, right? Correlation remains invariant under a change of origin and change of scale. So value will not change. The correlation value will not change. This property states that if the original pair of variables x and y is changed to new pair of variables u and v by effecting a change of origin and change of scale for both x and y, that is a and c are the origins of x and y, b and d are the scales of X and Y, then RXY was the correlation coefficient of X and Y, that would remain is equal to RUV. RXY will be the same correlation coefficient for RUV. However, they will have the opposite sign when B and D differ in sign. What are B and D? B is the scale of X, D is the scale of Y. So the change in scale that is happening. So if variable X is multiplied by 2 and variable Y is also multiplied by 2, in such cases, what happens? RXY will be equal to RUV. However, if B is multiplied by 2 and X is multiplied by 2 and Y is multiplied by -2, in such cases, RXY will be equal to minus RUV. There will be change in the sign. There will only be change in the sign and not value. So value doesn't change, only sign will change. This is correlation coefficient with regard to Karl Pearson's method. Clear with this? Yes. Next one. Spearman's rank correlation coefficient. Where do we use this? We use this for qualitative characteristics prominently. However, it can also be used for quantitative characteristics, quantitative data as well. Right? What do we do here? We assign ranks. We assign ranks to the values of X and Y, and then calculate the difference between the ranks. Right? So rank correlation can also be applied to the level of agreement between two judges. Okay. Now, what is the advantage here? Rank correlation coefficient is easier when compared to product moment because of the formula. Computation becomes easier, and it can be advocated to get a first-hand impression. So we are not looking into in-depth correlation analysis. We only want a on the face of it analysis. In such cases, we can go with rank correlation instead of Karl Pearson's. Now, how do we get this? It's equal to 1 minus 6 summation d square divided by n into n square minus 1, where d is the difference between the ranks. So we have X and Y values. We would assign ranks d1 and d2. Right, we would assign the ranks and we get D, which is d1 minus d2. Total of this D, this is total of the D. Summation d square. Okay, obviously summation d square d, then we have to take d square. Summation d square, 6 into summation d square divided by n into n minus 1. 1 minus of that, we get correlation coefficient. However, if we have tied ranks, in some cases the ranks could be tied, right? In such cases, what we have to do, we have to calculate t cube minus t by 12 for each of the tied ranks. For each of the tied ranks, t cube minus t by 12. What is t here? T is length of the tie. So if there is a tie at rank 2, okay, rank 2 has been allocated to 3 people. In such cases, what is the value of t? 3. Because length of the rank is 3, right? It's allocated to 3 people. So the value of t would be 3. So that has to be considered when there is a tied rank. So in such case, it would be 3 cube minus 3 divided by 12. Now, similarly, apart from rank 2, rank 5 is also tied between 2 people. Then I have to add to this 2 cube minus 2 divided by 12, because here the length of the tie is 2. Length of the tie is 2. Then the resultant addition of both should be added to d square value and then multiplied with 6. So it is not 6 summation d square plus t cube minus t by 12. It is 6 into summation d square plus t cube minus t divided by 12 whole divided by n into n square minus 1. Clear with rank correlation coefficient? Right. Then next one, coefficient of concurrent deviation. So here we are not calculating, we are not applying any formula as such. What are we doing? We are checking whether there is an increase or decrease in the value of the variable. Subsequent value of the variable, right? So it's a simple and casual method of finding correlation where we are not serious about magnitude of the two variables. It involves attaching a positive sign for a x value. If this value is more than the previous value, assign negative sign if it is less than the previous value. So same is done for y series as well. So obviously no sign will be allocated for first first value, because there is no previous value to check whether there is an increase or decrease, right? So if we have x and y, x values are 2, 3, 5, 2, and 8. Y values are 8, 5, 7, 6, and 9. Such cases, what do we do first? We assign signs. So for x values, what are the signs that we are attaching? First, obviously there is no sign, blank. Then second one, plus, because there is an increase, so we go with plus. Then
minus,
plus 3 and 5, there is an increase. Then
minus,
then
plus,
correct. Similarly for y, minus, correct, plus, plus. Then what do? We calculate the common factor, that is the common sign, that is the concurrent deviation. We call it C. So plus into minus, since they are of negative sign, both different signs, we go with negative. Plus into plus is plus, minus into minus is plus, plus into plus is plus. So all plus signs, we call it concurrent deviation. So total number of concurrent deviation is 3. Total number of deviations is 4. 4. Total number of deviations are 4. Out of the total number of deviations, concurrent deviations total is 3. Correct? Then we will apply this formula. 2 in 2c minus m divided by m. If 2c minus m is negative, then the correlation value will be negative. If 2c minus m value is positive, correlation is positive. Correlation is positive. Is that clear?
Yes.
Yes, 2c minus m is greater than 0. We take positive sign, both inside and outside the radical sign. And if 2c minus m is less than 0, then we take negative sign. So obviously, in this case also, it lies between -1 and +1. Correlation lies between -1 and +1. So these are the 4 measures of correlation: scatter diagram, Karl Pearson's, concurrent rank correlation, and coefficient of concurrent deviation. Next concept is regression. What is regression? Regression is based on an estimated relationship between the two variables, established relationship between two variables. We estimate the value of one of the variables for a given value of the other variable, right? That is regression. So for regression analysis, first what we have to do, we have to establish mathematical relationship. So for that, we have to check whether the values of x and y, whether x is dependent on y or y is dependent on x, right? So when there are two variables x and y, if y is influenced by y, that is, if y depends on x, then y is dependent variable, x is independent variable, correct? So if y is dependent on x, regression line of y on x will be y is equal to a plus bx. So if the regression equation, if y is equal to a plus bx, then x is the independent variable, because x value we already know, we are calculating y, that is why it is on the left hand side of the equation. Y is equal to a plus b into x. So y is dependent, x is independent variable. Y is equal to a plus b into x. In such cases, a and b are called regression parameters, where b is called the regression coefficient of, since it is y on x, regression coefficient of y on x, we denote it by b by x. If it was a reverse scenario where x is dependent variable and y is independent variable, then we'll have the equation x is equal to a plus b into y. In such cases, b is regression coefficient of x on y, we denote it by bxy. Correct? We denote it by bxy. Okay. Okay. Screen share is disabled. Yes. Okay. How do we calculate the bxy, byx, the regression coefficient? Byx is equal to covariance of xy divided by variance of x. Now, in calculation of R, correlation coefficient, how are we calculating? Covariance of xy divided by standard deviation of x into standard deviation of y. Correct? Same concept here. Since one of the variable is independent, one of the variable is dependent, we go with the independent variables calculation. What is the independent variable here? X. So we go with covariance of xy. Instead of standard deviation of x into standard deviation of y, we go with standard deviation of x into standard deviation of x. Therefore, it is variance of x. So easy to remember, which is the second variable here, x. So denominator should be variance of x. Covariance of xy divided by variance of x. Alternatively, we can also write this as r into standard deviation of y divided by standard deviation of x. R into, that is correlation coefficient into standard deviation of y by standard deviation of x. This is what, byx or bxy?
Byx.
Byx.
Yes, byx is r into standard deviation of y divided by standard deviation of x. Then, if again so once we get b, what is the other constant that we want? A. How do we calculate a? We know y is equal to a plus b into x. Using this equation, we know that the change of origin, change of scale, arithmetic mean concept, it does get affected by change of origin and change of scale. So if y is equal to a plus b into x, y bar will be equal to a plus b into x bar. We would know what is y bar, we would know what is x bar, and we know what is b. So a will be equal to y bar minus b into x bar. With this, I have calculated a, I have calculated b, I know what is x bar and y bar. So with this, we get a defined relationship between x and y, which can be used to calculate the value of y for a given value of x. Right? So how do we calculate regression in any, if we have been given x and y, our first job is to calculate x bar and y bar. Correct? Our first job is to calculate x bar and y bar. Then we have to calculate b. How to calculate b? Either if they have given us correlation, we go with that. If they have not given us correlation, then we go with covariance of xy divided by variance of x. For that, we want variance of x, and or alternatively, we can go with n summation xy minus summation x into summation y, that formula, right? So both alternative formulas can be used. With that, we calculate b. Once we have calculated b, then we will calculate a using this relationship. That is how we get the required relationship, and then we go with estimation. Is that clear? Yes. Now, yeah. Similarly, the other way around. If x is dependent on y, then regression line of x on y is given by x is equal to a plus b into y. X is equal to a plus b into y. So in such cases, same here, b will be considered as bxy, which is covariance of xy divided by variance of x or variance of y.
Variance of y.
Correct. Variance of y, or correlation coefficient into variance standard deviation of x divided by standard deviation of y. Right? So we, for same scenario, we'll calculate x bar, we'll calculate y bar, we'll calculate bxy, and then calculate a. How to calculate a? A will be equal to x bar minus b into y bar. Reverse. A is equal to x bar minus b into y bar. So that is how we calculate the two regression equations. Now, what are the properties of these regression equations? The properties are very important. Regression equation doesn't get affected by change of origin, but get affected by change of scale. Not unlike correlation coefficient. Correlation coefficient will not get affected by change of origin as well as change of scale, but in limited circumstances, the sign might get changed. Whereas regression coefficient, always it will not get affected by change of origin, but gets affected by change of scale. Gets affected by change of scale. So if x and y are the two original variables which have been changed to u and v, how are we changing it? U is equal to x minus a by p, where a is change of origin or change of scale?
Origin.
Yes, change of origin, where p is change of scale.
Change of scale.
Right? V will be equal to y minus b by q. In such cases, how do we get the value of b vu from byx? Byx will be equal to, since it's only getting affected by change of scale, we are not bothered about a and c, we are only bothered about p and q, right? Byx. So first we are going with y. So y's related change of scale is q. Q divided by p into bvu. Bxy will be equal to First is X. X related change of scale is P. P divided by Q into BUV. That is how we get the resultant regression coefficients. Resultant regression coefficients. Clear? Am I too fast?
No, sir.
No?
No, sir.
Okay. Now we have two regression coefficients. I want to calculate the respective arithmetic mean. How to do it? By solving the regression equations, solving those two equations. So the two regression lines intersect at x bar and y bar. Therefore, at any point in time for any given regression equations, if you want to calculate x bar and y bar, we have to solve the regression equations, simultaneous equations. Correlation coefficient between two variables x and y is simple geometric mean of the two regression coefficient. So R is equal to byx into bxy square root. Byx into bxy square root. So if they have given us bxy and byx, if I have to calculate R, I have to just multiply them, take the square root of it. Or if they have given one of the regression coefficient and R, if I have to calculate the other one, I have to use this particular relationship. Now, what would be the sign of the correlation coefficient? The sign of the correlation coefficient depends on the sign of the regression coefficient. Byx and bxy at all times will have same sign, plus or minus. Right? So if byx and bxy are positive, correlation is also positive. If bxy and byx are negative, correlation is negative. Correlation is negative. So that is how we can estimate or we can calculate regression coefficients or correlation coefficient if they have given us the other values. So these are the properties of regression coefficient. One is gets affected by origin but not get affected by change in scale but not get affected by change of origin. So if I have byx, if I have to calculate bvu, what I'll do, byx is equal to q by p into bvu, sorry. Bxy will be equal to p by q into buv. And if I have been given two regression equations and I have to calculate x bar and y bar, how to do it? By solving the simultaneous equations. Right. Then if they have given us the two regression coefficients, how to calculate the correlation coefficient? Multiply and take square root. Multiply the two regression coefficients and take the square root. What is the sign of the correlation coefficient? It depends on the sign of the regression coefficients. If both regression coefficients are positive, correlation is positive. If the regression coefficients are negative, correlation is negative. Correlation is negative, right? So this is regression analysis. This is regression analysis. Next concept in that particular chapter, a small concept, is probable error. Okay, now where do we use this? Normally, we can calculate correlation and regression if we have a reasonable number of values. But in case of population, where we are calculating the values for sample and then appropriating it to the population, in such cases, we cannot directly calculate correlation for the sample and say that this is the correlation of the population. Why? Because there would be sampling errors. So the correlation that we have calculated for the sample might differ with respect to the population. So in such cases, we apply the concept of probable error. Probable error is the method of obtaining correlation coefficient of the population using the correlation coefficient of the sample. So our first job is to calculate the correlation coefficient of the sample. How do we calculate? The same way that we have already learned, Karl, Pearson or Spearman or concurrent deviation, etc. Same way we will calculate the correlation coefficient for the sample. Once we have calculated the correlation coefficient for the sample, then we will apply the concept of probable error. Probable error is equal to 0.6745 into 1 minus r square divided by root n. So what is probable error? Probable error is the variation that could be there in the correlation of the population. Variation that could be there. So 0.6745 into 1 minus r square divided by root n. Alternatively, you calculate standard error. Standard error is 1 minus r square divided by root n into 2 by 3. You will get the probable error. Once you have the probable error, what you have to do is the correlation coefficient of the population is equal to correlation coefficient of the sample plus or minus the probable error that you have calculated. So if let's say we have the correlation coefficient as 0.67 of the sample, this is R. Probable error that we have got is 0.05. So in such cases, the correlation coefficient of the population would be 0.67 plus or minus 0.05, which means it would be in the range of 0.72 and 0.62. How did we get 0.72 and 0.62? 0.67 plus 0.05, 0.67 minus 0.05. So it would be in the range of 0.72 and 0.62. So for the population, the correlation coefficient would be in the form of a range. It will not be a single value, unlike correlation coefficient of the sample. Okay, so first we have to calculate the correlation coefficient of the sample R, then calculate probable error. How do we calculate probable error? 0.6745 into 1 minus R square by root 10. Then we have to limit the correlation coefficient of the population, which is R plus or minus probable error. R plus or minus probable error. Now, with regard to this probable error, what are the assumptions that we are taking? If R, the correlation coefficient of the sample, is less than the probable error. So the correlation coefficient of the sample, let's say 0.01, but the probable error that we are getting is 0.05. So correlation coefficient is less than the probable error. In such cases, we say for the population, there is no correlation at all. So there is no evidence of correlation. However, if R is greater than 6 times the probable error, it means that there is a strong presence of correlation. If R lies between, since R lies between -1 and +1, probable error cannot be negative. Probable error can never be negative. PE formula is valid. This probable error formula is valid only if the correlation that we have calculated from the sample, that sample should be a random sample and the population should be normal. Population should be normal and the sample should be taken from using the concept of random sampling. Only then probable error concept holds good. Then if two variables X and Y are independent, then we say correlation coefficient is 0 because they are independent. But just because there is the correlation coefficient is 0, we cannot say that the two variables are independent. The converse. If two variables are independent, correlation coefficient is 0. But if correlation coefficient is 0, we cannot say that the two variables are independent. Why? Because the correlation coefficient that we get using Karl, Pearson's, etc. are linear relationship. So there could be some non-linear relationship between the variables. Okay, so the converse of the statement is not true. That is, if the correlation coefficient between two variables comes out to be 0, then we can conclude that no linear relationship exists between the two variables. No linear relationship exists between the two variables. This does not rule out the existence of non-linear relationship between the variable, but this does not mean that X and Y are independent. Now, in certain cases, two variables are independent, X and Y are independent, but there is one more variable called Z. Because of this variable Z, for every change in X, there is a change in Y, not directly, indirectly. So for every change in X, Z changes. For every change in Z, Y changes. So X and Y are not related, X and Y are not dependent, but there is, because of one existence of a third variable, there is a change in these two variables correspondingly. Such a relationship, such a correlation is called spurious or nonsense correlation, because there is no direct relationship. The values are changing just because of a third variable. Just because of a third variable. Example, production of steel and production of production of rice. Manufacture of steel and production of rice. In such cases, for 2000 and 2010. Now 2000 production, let's say manufacture of steel is 100 tons and production of rice is 1000 tons. 2010, it became 500 tons and here it became, let's say, 8000 tons. Now, there is a, for every change in steel, there is a change in production of rice. But is it because of change in production of steel, this price of the production of rice is changing? No, right? It is not because of change in steel that the production of rice is changing. It is because of a third variable called time. It is because of a third variable called time. So even though there is a change among them, even though we will get some correlation, if we calculate, you apply Karl-Pearson's formula, we'll get a correlation value. But that correlation is called spurious or nonsense correlation. Yes. So that is the review of correlation and regression. Now, there is something called coefficient of determination. R is correlation. R square is coefficient of determination. What is coefficient of determination? It means that this whatever calculation that we have, that covers so and so percentage of the data that we have, variation that we have. So if R is 0.6, coefficient of determination is 36%. That is 0.6 whole square, 0.36, 36%, which means that 36% of the variation among the variables have been accounted for by the factor under consideration. Remaining 64% is because of other factors. So simple to understand, X and Y. X is 1 and Y is 2. If X becomes 2, Y is changing to 3. So let's say the correlation that we get is 0.5. So what is the coefficient of determination? This is R. What would be coefficient of determination?
25%.
25%, 0.5 the whole square, which is 0.25, 25%, which means that this change in Y that we are looking into, out of that, 25% is because of change in X. The balance change, that is 75%, is because of other factors. So that is coefficient of determination, R square. If I calculate 1 minus R square, we get coefficient of non-determination. We get coefficient of non-determination. Regression analysis is concerned with establishing a functional relationship between the two variables and using this relationship to make future projection. This can be applied, unlike correlation, for any type of relationship, linear or curvilinear. In case of correlation, we discussed Karl Pearson can be applied only for linear, whereas in regression, there is no such restriction, linear or curvilinear. We can use that concept of regression analysis for all type of relationship. Two lines of regression coincide, becomes identical when R is equal to -1 or +1. So when there is a perfect correlation, whether it's positive or negative, the regression equations become identical. They coincide. Similarly, if R is equal to 0, regression equations are perpendicular to each other. So this can be asked in the exam. So when the two regression equations coincide, becomes identical when R is equal to -1 or +1. If R is equal to 0, the regression equations become perpendicular to each other. Regression equations become perpendicular to each other. Clear with this? Yes, this is regression analysis. Can we look into a problem with regard to this? Any doubts before that? Right, a simple question. Covariance between two variables, it's 8.4. Variances are 25 and 36 respectively. Calculate Karl Pearson's coefficient of correlation between them.
B 0.28.
0.28.
Very good, 0.28. How did we get that? What is the relationship that we are considering? R is equal to covariance of XY divided by
Variance of X and variance.
standard deviation of X.
Standard deviation of X
Not
into
variance
standard
of X
deviation
into
of
variance
Y.
of Y. It's standard deviation of X into standard deviation of Y. So 8.4 divided by variance of X is 5. Sorry, standard deviation of X is 5. Standard deviation of Y is 6. So 8.4 divided by 30, 0.28. Right? So this is how we will calculate Karl Pearson's correlation coefficient. Is that clear? Yes. So the other, that is rank correlation and concurrent deviations, we had already discussed the examples, right? If you want one example of rank correlation, we can consider. So we have X and Y. X values 125, 150, 160, 135, and 180. Y values 220, 240, 225, 280, and 245. So what is the first job? First job is to assign ranks. How do we assign ranks? For X, which is the rank number 1?
180.
180.
Yeah, 180.
160, 150.
160, 150.
135,
135,
135, 120.
135, 125. For second, Y?
280,
280.
245, 240,
245,
240,
240,
225,
225, 220.
225, and 220. Correct. Then what are we supposed to do?
calculate the D.
Difference between ranks, D, correct? Difference between ranks. 5 minus 5 is 0. 3 minus 3 is 0. 2 minus 4 is
-2.
4 minus 1 is 3. 1 minus 2 is minus 1. Then
Square.
D square.
very good. D square. 0, 0, 4,
4,
9 and
9,
1. Total summation D square is 14.
14.
Then we will apply the formula. What is the formula?
1 minus 6 summation D square by n into n square minus 1.
N into n square minus 1. So 1 minus 6 summation D square is 14. What is n?
5.
Number of values 5. 1, 2, 3, 4, 5. Correct. 5 into 5 square is 25. 25 minus 1 is 24. So 6 ones are 6 fours are 14 divided by 20 is 0.7. 1 minus 0.7, 0.3. Correct? Yes. So the correlation coefficient that we get is 0.3. This is how we go with rank correlation. However, in any of this, let's say, instead of 160 here, we had 150. Then both would be rank 2. So what do? We put 2.5. Right? We'll put 2.5 there. 2 and 3. 2.5, 2.5. Then what would have done? This would change. D will change. So this is 0.5 minus, and this is minus 1.5. 0.5 square is 0.25. 1.5 square is 2.25. Accordingly, summation D square would have changed. 2.5, 3.5, 12.5. Then what we have to do?
T cube minus T by 12.
T cube minus T by 12. So what is the value of T here?
2.
2, because only 2 values, right? Length of the tie is 2. So 2 cube minus 2 divided by 12. 2 cube is 8. 8 minus 2 is 6. 6 by 12 is 0.5. Right? This 0.5, what we have to do? We have to add or subtract to summation D square? Add. Right? So it would be summation D square plus T cube minus T divided by 12. So summation D square is 12.5. 12.5 plus 0.5 is 13. 13 into 6 divided by 5 into 24. That would have been 1 minus of that would have been the correlation coefficient. Clear?
Yes, sir.
Everyone understanding?
Yes, sir.
Yes,
sir.
Yes. Now for the same thing, can we go with concurrent deviation? So concurrent deviation, first we have to allocate signs. For x, what are the signs that we'll allocate? First, for the first value,
No, sir. We don't
no
have.
sign, correct? Then second,
Positive.
positive.
Add.
Okay, we'll say 160. If there is no change, then it will be blank, right? So in such cases, concurrent deviation cannot be calculated. Coefficient of concurrent deviation cannot be calculated. 150 to 160
Plus.
minus
Plus.
for y
Plus.
plus minus
Plus.
plus minus. So what would be the total deviations? This is plus.
Minus.
So what is the number of concurrent deviation?
1.
M.
Number of
Very good. M. M. Yeah. C is 1. M is
4.
total number of deviations is 4. So 2C minus M divided by
M.
M.
correct? Is the formula correct?
Yes, sir.
Yes. So 2 into C. 2 minus 4 divided by 4. So we'll ignore the negative in the numerator. So 2 divided by 4 is 0.5. Root of 0.5 would give us the correlation. Plus or minus?
Minus.
Minus. Why? Because 2C minus M is negative. Since 2C minus M is negative, the correlation would be minus. Negative. So that is how we calculate the correlation coefficients. Is that clear? Can I go to the next chapter then? Yes? Okay. The last chapter in statistics, index numbers. Index numbers, objective. What are the objectives of studying index numbers? So first, what is index number? Index number is a ratio or average of ratios expressed in percentage. So it would be in percentage. It will always be into 100. And 2 or more time periods are involved, out of which one will be base period. Right? One would be base period. what is the index number for base period?
100.
100, correct. The value at the base time period serves as the standard point of comparison. An index time series is a list of index numbers for 2 or more periods of time where each index number employs the same base year. Index numbers are studied for forecasting, inferencing, etc. Right? Broad classification: simple index number, composite index number. If we are calculating index number of one variable, we call it simple index numbers. 2 or more variables, we call it composite index numbers. Right? Most of the index numbers are composite in nature because there will be more than one variables at all times. For construction of index numbers, there are some important criteria that we have to consider. Right? Various points that we have to consider. First one is selection of data. So to calculate index numbers, we want data. So the data that we select should be appropriate. Obviously, when we are calculating the index number, we cannot consider all information with regard to that particular index. So we go with sampling. So when we are going with sampling, random sampling techniques should be followed, preferably stratified random sampling. So it ensures that comparability of data is maintained. Right? However, difficulties arise in selection of commodities because relative importance of the commodities keep on changing. Now, when we are calculating consumer price index, we have to consider the prices of the prices of the commodities which the consumer consumes. Now, what are the commodities that the consumer consumes changes over the period of time. Right? So the selection of commodities becomes utmost important, and it would be very difficult to select the commodities. Next, selection of base period is very important. It's not that we can select any year as a base year. No, we should ensure that the base year should be a normal year. There should not be any abnormal, extraordinary event in that particular year. It should be relatively recent, right? It should not be a very old year. Then base period when we are looking into, when we are calculating the index number with regard to a base period, we can have 3 variants of base. It could be fixed base, it could be chain base, or it could be average base. Right? All the 3 is possible. Base period index will always be considered as 100. Then, yes, once we have the base period and the data, when we are calculating index number, we cannot give equal weightage to all commodities. When we are calculating consumer price index, we cannot give equal weightage to rice, to wheat, as well as to other consumables that we have used like sugar, etc. Obviously, we cannot give equal weightage. So we have to select appropriate weights. Right? Selection of appropriate weights is very important. So normally in case of price indices, what is the weightage that we give? Quantity. Quantity is the weight that we consider. Then use of average. Now we have multiple commodities. So we have 100 commodities. So we will get 100 different index numbers for consumer price index. But we'll require only one. So what we have to do? We have to average it out. Right? So we have to calculate the average. So which is the best average in case of index numbers? Geometric mean. Yeah, geometric mean is the best average. However, for ease of calculation, simplicity, we go with arithmetic mean. Right? We go with arithmetic mean. Then choice of variables. Index numbers are constructed with regard to price or quantity. Right? We have to decide about the unit. For example, in price index numbers, it is necessary to decide whether we are going with wholesale price or retail price. If it's a wholesale price index, we have to go with wholesale price. However, in consumer price index, we'll go with retail price. Right? So the choice would depend on what the purpose of that index number. So choice of variables are important. Then last point, selection of formula is very important. We have multiple formula for calculating index numbers. So selecting appropriate formula is very important. So before looking into the formulas, we have some concepts called relatives. Right? What are these? We have 3 different types of relatives: price relative, quantity relative, and value relative. What is price relative? Price relative is the ratio of price of a commodity in the current year, that is given year, to that of the base year into 100. P1 divided by P0 into 100. Similarly, quantity relative is quantity of the current year, quantity of the base year into 100. Value is price into quantity. So price of the current year divided by into quantity of the current year divided by price of the base year into quantity of the base year into 100 is value relative. So price relative, quantity relative, and value relative. We use those in the calculation of index numbers. Now, when we are calculating index numbers, we can have link relative or chain relative. In link relative, what do we do is price of current year, price of last year, price of second year divided by not price of base year, price of first year. We are linking. This is link relative. P3 divided by P2, P4 divided by P3, etc. So on. We use this subsequently. We'll discuss about it, right? However, chain relative is denominator will always be the base year. Denominator will always be the base year. P1 divided by P0, P2 by P0, P3 by P0. This is chain relative. So when we discuss about calculation of chain index numbers, we'll apply both chain relative as well as link relatives to calculate chain index numbers. We will discuss about it when we look into chain indexes. With regard to methods of construction of index numbers, broadly into two: aggregate and average of relatives. Aggregate method, average of relatives method. Under aggregate method, we have simple aggregate, weighted aggregate. Under average of relatives also, we have simple average of relatives, weighted average of relatives. Simple average of relatives and weighted average of relatives. Now, simple aggregate method is simple. We have prices of different commodities, add all the prices of the commodities. So summation P1, prices of the current year, all prices, divided by summation P0 into 100. This is simple aggregate method. Summation P1 divided by summation P0 into 100. What is the advantage here? It's easy to understand and calculate. However, the disadvantage is if units are changed, index number will also change. So it doesn't satisfy unit test. Doesn't satisfy unit test. Why? Because now price of commodities that I have taken, rice, wheat, sugar, let's say three commodities, 50, 40, and 45. These are the prices that we have considered. So we have considered the prices per kg. Subsequently, if we are changing the prices of the commodities, we are considering per 10 kg, then obviously my index number will change because the prices will change. So it's not satisfying unit test. So if units are changing, index number will also change. If units are changing, index number will also change. That is the disadvantage in case of simple aggregate method. That disadvantage is overcome in the second method, which is simple average of relative. In simple average of relative, what are we doing? We are not adding up all the prices. Instead, we are calculating index numbers, price relatives for each commodity. So if we have rice, wheat, and sugar, the prices are 40, 45, and 50. And this is P1. P0 was 30, 35, and 40. We calculate price relatives for each. 40 divided by 30 into 100, 45 divided by 35 into 100, 50 divided by 40 into 100. So we calculate price relatives for each commodity and then calculate the average of these price relatives. So obviously, if there is a change in units, the index number will not change. So even if you consider 1 kg or 100 kg, the index number will remain the same. The relative will remain the same. So one of the drawbacks of simple aggregate, which is the unit related drawback, is overcome with the help of simple average of relatives method. Here, what do? We invert the actual price for each variable into percentage of the base period. These percentages are called price relatives. Index number then will be the average of all the relatives. One big advantage is they are pure numbers free from units. Price index number computed from relatives will remain the same regardless of the change in the units. So it satisfies unit test. Quantity index can be constructed by which are expressed in divergence units. So we have discussed about simple average of relatives price index. Similarly, quantity index can also be calculated. However, what is the disadvantage? Equal importance is given to all the commodities. Right? So equal importance is given to all the commodities. Therefore, the index number that we get might not be the appropriate index number. That is the disadvantage of simple average of relatives. So we have discussed two types, simple aggregate and simple average of relatives. In simple aggregate, what are we doing? We're first adding up the prices and then calculating index numbers. Whereas in simple average of relative, first we are calculating index number individually and then add up and calculate the average of it. That is the difference between simple aggregate and simple average of relative. Is that clear? Yes?
Yes.
Okay. Then to overcome the weakness of equal importance, giving equal importance under the first two method, we have weighted indices. Under that first one, weighted aggregate index numbers. So in weighted aggregate index numbers, what do? We assign weights. So in case of price index, the weights that we normally assign is quantity. However, in certain cases, we even assign values as weights, right? So with regard to weighted aggregate index numbers, we have various formula to calculate weighted aggregate index numbers. Last pair, Pasteur, Marshall, Edgeworth, Fisher. So last pair formula, what is the weight? Q0. Base year quantity is weight. So P1, P0 would remain the same. Here it would be Q0, Q0. So summation P1, Q0, P0, Q0 into 100. Whereas in Pasteur, Q1 is the weight, current year quantity is the weight. So P1, P0 would remain the same. Q1, Q1. So summation P1, Q1, summation P0, Q1. Whereas in Marshall Edgeworth, average of current year and base year quantity is considered as weight. So further simplifying, the formula would be summation P1, P0 would remain the same into Q0 plus Q1 into Q0 plus Q1 into 100. Fisher's is geometric mean of last pair and past year. So simple. Square root of summation P1 Q0 by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1. So all the four formulae very important. We have to remember. We have to remember this formula. Weighted average, the next method. This is weighted aggregate index. Weighted average of relative. Weighted average of relative is similar to
last year's price.
Yes, last year. So what are we doing here? We are giving value as the weight. So we know that weighted average, simple average of relative is summation P1 P0, right? So here what are we doing? We're multiplying summation P0 Q0 divided by summation P0 Q0 as weights. Therefore, further simplifying this, we get summation P0 P1 Q0 divided by summation P0 Q0 into 100. Therefore, this is same as last pair's index numbers. So weighted average of relative is same as last pair's index numbers. But this is weighted arithmetic mean, weighted arithmetic mean. Similarly, we can have weighted geometric mean as well. Weighted geometric mean can also be used. Weighted average means we can have anything as average, right? So we can have geometric mean as well as arithmetic mean. Normally for our calculation, we go with arithmetic mean. However, geometric mean can also be used. So these are the different types of index numbers. Different types of index numbers. Next one is an extension of this, which is chain index numbers. What is this chain index numbers? In chain index numbers, what happens is, if in the normal cases, what happens, the base index would be fixed. Base index would be fixed. So irrespective of the number of years for which index numbers are calculated, base would be fixed. So comparison might become improper. So for that, we go with chain index numbers. So the base based on which we are calculating the index numbers would be changing. The base will be changing. However, if it is desired to associate their relatives to a common base, the result may be changed. So it's not that we are changing the base abruptly. We are giving the importance to the original base also, but we are also giving importance to the recent index numbers. So how to do that? We will calculate link relative. What is link relative? P1 by P0, P2 by P1, P3 by P2. This is link relative. Current year by previous year, current year by previous year, irrespective of the base year. So that is link relative. So link relative of the current year will be calculated into chain index of the previous year. Divided by 100 will give you chain index of the current year. So link relative for the first year will always be 100. Chain index for the first year will always be 100. Okay, link relative for the first year will always be 100. Chain index will always be 100. So if I have the prices of the commodities P1 and P0, sorry, P1 or rather 2010, 2011, 2012 and 2030. First year 150, second year 180, 240 and 300 are the prices. Now, if we are calculating normally index numbers, how do we go? This is 100. 180 by 150 into 100, we get this, and we get this. However, if I go with chain index number, what happens? What is the chain index number for the first year?
100.
100.
It would remain 100. First year, it would be 100. Second year, first I have to calculate link relative. What is the link relative we have? 180 by 150. Current year by previous year into 100, which is 120, I think. 120 or 125? 120.
120.
Correct? 120. What is the chain index of the previous year? 100
100.
divided by 100. So chain index is 120 itself. Third year, what is my link relative? How do I calculate link relative for third year?
240 divided by 180 into 100.
Very good. 240 divided by 180 into 100, which is
133.
133.33. 133.33 into 120 divided by 100. Why 120? Chain index of previous year. 120 divided by 100. So into 120 divided by 100, we get 159.99, or we can say 160. Then next one, what is the link relative?
300 divided by 240 into 100.
300 divided by 240 into 100, which is
125.
125. 125 into chain index of last year is 160 divided by 100.
200.
200. Yes. So this is chain index numbers. This is chain index numbers. Clear with this? Yes. So this is chain index. So we have discussed about price index numbers. Similarly, we can calculate quantity index numbers also. In case of quantity index numbers, what would be the weights that we give? Prices, right? Prices will be the weights. The same methods, simple aggregate. In simple aggregate price index number, we had summation P1 by summation P0. Here it would be summation Q1 by summation Q0. Simple average of relatives, we were calculating price relatives first, adding up the price relatives divided by n. Here, instead of price relatives, we calculate quantity relatives individually. Weighted aggregate also, we have same four methods: Laspierre, Pasche, Marshall, Edgeworth, and Fisher. Laspierre, there it is summation P1 Q0 by P0 Q0 into 100. Why? Because that was price index numbers. Here, since it is quantity, first we'll have Q1 by Q0. Since it is Laspierre, base year's price would be the weight. So P0, P0. So summation Q1 P0 by summation Q0 P0. In case of past year, Q1 Q0 only, but current year prices would be the weights. So Q1 P1 by Q0 P1. In case of Fisher, it is again geometric mean of Laspierre and Pasche. Right? Geometric mean of Laspierre and Pasche's index numbers. Is that clear? Similarly, weighted average of quantity relatives, same. First, you calculate quantity relative, multiply it with the value P0 Q0. We get the weighted average of quantity relatives. Okay, then value indices. So value indexes, what is value? Value is price into quantity. So how do you calculate value index? Value of the current year by value of the base year. So summation P1 Q1 by summation P0 Q0 into 100. This is value index number. So this is calculation of index numbers. Now, what are the limitations of this calculation? As index numbers are constructed mainly based on samples, there would be sampling errors creeping. So it is unavoidable. Sampling errors are unavoidable. Since index numbers are based on some selected items, they simply depict the broad trend, not the real picture. Now, even though we calculate consumer price index, we're not considering all the commodities that the consumers will use. Only some selected commodities. So we are not getting the real picture. We are only getting the broad trend of the inflation in the economy. Then, since many methods are employed, selection of appropriate index number is very important. Each index formula will give us different index numbers. So that is also one of the limitation of index numbers. Having said that, it has lots of applications. The usefulness of index numbers, framing suitable policies in economics and business. They provide guidelines to make decision making, reveal trends and tendencies in making important conclusions. They're important in forecasting future economic activities. right? And deflating because of inflation. Price of 100 rupees today will not remain 100 after 2 years, right? So that because of inflation. So how do we calculate that deflated value of that particular product using index numbers? Cost of living index measure change in the cost of living over a given period. These are the uses of index numbers. Now there is a couple of concepts here. One is deflating time series. Second one is shifting and splicing of index numbers. Deflating, just now I had discussed. What is deflating? Calculating the current value in terms of real economic terms. So how do you calculate that? Current value divided by the price index of the current year. Current value divided by price index of the current year will give you deflated time series. So value of a product is 250. The price index of the current year is 125. In such cases, current value divided by price index into 100. So base year it was 100, correct? So 250 divided by 125 into 100, 200. So that means that this is the real change in the value of that product. Now, simple, I'll give you an example. In 2010, the price of the product was 180. Okay, at that time, what is the base index number? 100. 2020, the value of the product became 250. So going with the real terms, what is the change? What is the increase?
70.
70, correct? Increase is 70. But in 2020, the index number, price index is 125. So because of inflation, there will be a normal automatic increase in the price. So what is the automatic increase in the price? We have to check. For that, we have to go with deflated value. So if present value is 250, what would have been the value of in 2010 if there was no, if we ignore that inflation? So 250 is when the price is 125. What would have been the price when the price is 100? It would be 200. So the real increase is only 20 rupees. From 180, it became 200. The balance 50 rupees is because of inflation. So this is calculated using the concept of deflating the time series, bringing the time series back to its original value. The price is back to its original value. Next is shifting and splicing of index numbers. So what happens in shifting and splicing? Shifting of index numbers is, now we are following the base year of 2010. Now I want to change the base year to 2016. This is shifting of index numbers. Splicing is, I have one set of index numbers from 2010 to 2016 with base of 2010. Another set of index numbers from 2016 to 2022 with base as 2016. Now we have to merge both. That is called splicing of index numbers. So how do we split and splice? How do we split and splice? In case of splitting, we'll check. So we have 2010, 11, 12, 13, 14, and 15, 16. Okay, prices are 80, 85, 90, 100, 120, 125, and 140. Okay, so base year is 100. Base year index would be 100. Correct. What would be the index number for the second year? What is the index number?
One or 6.25.
106.25. How did we get this? 85 divided by 18 to 100. Correct. Similarly, 90 divided by 85 or 90 divided by 80?
80.
Base year. So 90 divided by 80, 112.5. Right? 100 divided by 80 is 125. 120 divided by 80 is 150. 125 divided by 80 is 156.25. 140 divided by 80 is 175.
170.
Now what I want to do is I want to change the index numbers with base 2013. I want to shift the base to 2013. In that case, what would be the index number for 2013?
100.
Yes, index number for 2013 becomes 100. In that case, what would be the index number for 2010?
80.
80. Why? Because index number of 2013 price is 100. index number, whereas the price of first year 2010 is 80, price of 2013 is 100 into 100, so we get 80. Similarly, 85, 90, 120, 125, 140. So if I were to change it to 2014, 2014 index number would be 100. In that case, what would be the index number of 2010? 80 divided by 120 into 100, which is
66 points.
66.67. Is that clear? Right? This is how we shift the index numbers. This is how we shift the index numbers. Similarly, splicing happens. Let's say 2012, 13, 14, 15, we have 1. 15, 16, 17, and 18, we have 1. Okay. So we have 100, 120, 125, and 140 as the index numbers. 100, 120, 125, and 130 as the index number. Now what I have to do, I have to splice, merge them. So 14, 13, and 12. How do I merge? 15 would become 100. So if 15 is 100, what would be 12? 100 by 140 into 100, which is?
71.43.
Yes, 71.43. Then 120 by 140 into 100 for 13.
85.71.
85.71. 125 by 140 into 100.
89.29.
89.29. So this is how we merge two sets of index numbers. This is splicing of index numbers. So this is shifting and splicing. Shifting is base period itself is shifted. Splicing is two sets of index numbers are combined. Two sets of index numbers are combined. Okay, so that is shifting and splicing. Next, we have test of adequacy, very important. We have 4 tests: unit test, time reversal test, factor reversal test, circular test. Unit test is change in the units should not affect the index number. So apart from simple aggregate index numbers, all other simple aggregate, not simple average. Apart from simple aggregate index numbers, all other index numbers satisfy unit test. Second one is time reversal test. That is P10 into P01 should be equal to 1. That is index number calculated by current year by base year into base year by current year. Both, if you multiply the index numbers, we should get 1. Right? P01 is index number for time 1 on 0, P10 is 0 on 1. So which is the index number which satisfies time reversal test? Fisher. Fisher. Last person passer doesn't, right? So Fisher's index number satisfies. Factor reversal test is price index number into quantity index number should be equal to value index number. Right? That is factor reversal test. Again, Fisher index number satisfies this. Since Fisher index number satisfies both time and factor reversal test, it is considered to be ideal index number. Next one is circular test. Now, what is circular test is, I have 2 sets of index numbers. One is of 1970 with base 1965. Second one is 1975 of base 1970. Okay. Now, I wanted to calculate the index number of 1975 with original base of 1965. So to calculate that, if I can multiply these 2 index numbers and get this index number, then we consider a circular test to be satisfied. So we'll take this example. 1970 with base of 1965 is 200. 1965 with base of 1960 is 150. So 1970 with base 1960. 1970 with base 1960 should be 200 into 150 by 100, 300. If it is satisfied, then we say circular test is satisfied. Okay. None of those 3 index numbers, including Fisher index number, satisfies this. However, price relative, simple geometric mean of price relative, the normal average arithmetic mean of price relative that we do, summation P1, P0 divided by N, that doesn't satisfy. Geometric mean of price relative satisfies, and weighted aggregate method with fixed weights satisfy circular test. Weighted aggregate method with fixed weight satisfies circular test. This is index numbers. Okay, so we have various types, different types of index numbers that we have discussed. That's very important. Then we discussed about shifting, splicing, calculation of chain index, right? And deflating, that is important. Then testing of adequacy of index numbers. So can we look into some questions?
Yes, sir.
Yes. Index number for 2012, taking 2011 as the base year from the data by using simple average of price relative method. So how do we calculate simple average of price relative? What is the steps involved? Simple average of price relative.
Calculate price relatives and average.
Price relative for all individually, A, B, C, D, E, correct? So for A, how do you calculate price relative?
125 by
125 by
100.
Yes, 125 by 115 into 100. Similarly, 117 by 108 into 100 and so on. So this is how we calculate price relative. Add up all the price relatives divided by
Number of years, N.
number of
Commodities, A, B, C,
N,
D.
number of commodities. N. So here it is 5.
5.
So if we do that, we get simple
111.
average of price relatives, which is
111.
111, correct. We get 111. So the price relatives that we get here are 108.7, then 108.33, 113.68, and 118.75, 105.56. So these are the different price relatives that we get. Total is 555.02 divided by 511. 111 is the index number. Next question. Suppose a business executive was earning 2050 in the base period. What should be his salary in the current period if his standard of living is to remain the same? So sum of all the weights is 25. Sum of the weights into prices is 3544, the value. So here we have to apply that deflation concept. How did we get that? 3,544 divided by 25. We get the basic value of current year into 2050, the base period price. So this is the inflated index number. What is the index number that we get? 3544 divided by 25.
141.76.
141 point something. So this is the current year index number. Base year index number is 100. So if base year price was 2050, what would be the current year price? 2050 into 141 divided by 100, which is 2906. 2906. Next one is simple. Calculate the past days index numbers. Tell me the formula. Calculation is simple. Past days formula.
P1Q1 by
Summation P1Q1 by P0 Q1 into 100.
Yes, summation P1Q1 by P0 Q1 into 100. So for that, we want P1 Q1 and P0 Q1. So we need not waste time in calculating P0 Q0 and P1 Q0. We only require two columns, P1 Q1 and P0 Q1, total of it, and you'll get the past year's index numbers. Okay, 261.36 is the answer. The calculation is easy. Next, index numbers are not helpful in
identifying errors.
So framing economic policies, we want revealing trend. Yes, forecasting was also used, but by calculating index numbers, we're not identifying any errors here, right? So it's not helpful in identifying errors. Weighted average of price relatives of commodities when the weight is equal to the value of commodities in the base year yields which index number?
Last year.
Last year. So what are they saying? Price relative of the commodity. Price relative is P1 by P0. Weight is equal to value of commodity in the base year, which is Q0 Q0. So summation P1 Q0 by summation P0 Q0 is last year's index. So last year's index is the correct answer. Clear with this? Fairly understood?
Yes, sir.
Yes. Are we confused?
Yeah.
No, sir.
No, sir.
Yes. Clear with this. So with this we are done with our discussion on statistics. So what we can do, obviously we will not be completely thorough with all the concepts. That is why we have next 6-7 days, right? We have to prepare. So we have to take this as a base and then build upon it. Clear? Yes, we have some doubts. Okay. Should we solve section C in the ICI material? Suggested not to solve the set C related questions, not to solve. However, if you have time and patience, go and solve it. And what is the weightage for calculus? When we discuss mathematics, we'll discuss about calculus. Okay, done. So with this, can I move on to logical reasoning?
Yes, sir.
Yes.
Yes, sir.
So can we take a break and then start with logical reasoning, or we'll start and then take a break later?
As you say, sir.
No, if you have the intensity right, then we'll start with logical reasoning later. After completing a chapter or so, we'll take a break.
Okay.
Everyone has the intensity? Yes.
Yes, sir.
Yes. Okay, then we'll start with logical reasoning. With regard to logical reasoning, unlike statistics, no formulas to remember, right? So no formulas to remember, no concepts as such. It's pure general knowledge, pure common sense. So that is why for sometimes it becomes difficult. Logical reasoning, we have 4 different chapters. One is number series, coding, decoding, odd man out. So here, first chapter, we have four concepts. Number series, it includes alphabets, numbers, pattern, then coding and decoding, where a particular word would be coded into a different word. So using that relationship, we have to identify the code of another word. Or decoding, they would have given us the coded word. We have to decode what is that word all about. Then odd man out. Odd man out, we have learned odd man out since our childhood, right? So we have to identify which is the odd one in that particular set pattern. So series, there can be 2 types of series that they can ask us. One is number series, second one is alphabet series. In case of number series, we have to identify the pattern. There will be some pattern in which that series would have been set. So they may give us this pattern: 2, 3, 5, 11, 13. What is this? 7. Why? These are all prime numbers, correct? So there's a pattern here. Similarly, we can have 1, 8, 27, and 125.
64.
64. Why? These are
Cubes.
cubes, right? So it need not be such straightforward patterns. It could be a combination of 2. It could be 1 plus 1 cube, 2 plus 2 cube, 3 plus 2 cube, or 2 cube minus 1, 3 cube minus 1. The patterns could be such as well. So we have to identify the pattern, and then one number among the pattern would be a missing figure. We have to identify that missing figure. So most of the times the pattern would be easily identifiable. However, 1 or 2 questions would be slightly tricky in this. Okay, there generally from this chapter 5 questions would be asked on an average, 5 questions, out of which 2 to 3 questions could be from number series. Right? So 1 question would be tricky. The other 2 questions would be easily answerable. That tricky question, what I suggest is, obviously identifying the pattern could be difficult in such cases. We'll answer one of such questions also. Could be difficult. So in such cases, we may go with the options that they have given. Try and match that option, whether we can create some pattern out of the options that they have given. Okay, that is how we can attack such questions. Similarly, we can get alphabet series as well. In case of alphabets, we have to be aware of the numbers each alphabet have, the order of the alphabet. So A is the first alphabet, B is the second one, Z is the last, 26th alphabet, so on. So we should know this arrangement. We should know this arrangement. So based on that, questions will be asked. Okay, the pattern would be based on this. The series would be based on that. Apart from numbers and alphabets, there could be letter-based series as well. Alphabet is individual, whereas letters clubbed. So they can give you A, B, A, B, B, So such series patterns also can be given. So that is letter series. Okay, so these are the different types of series based on which questions can be asked: number series, alphabet series, and letter series. Next one is coding and decoding. In coding and decoding, what happens is, so they would have coded the word read as S, F, B and E. Okay, S, F, B and E. Now they will ask us to code the word book. So we have to code. How are they code? How have they coded?
One
Next
letter,
alphabet.
which
Next letter.
next letter.
Yes. So R next letter is S. E next letter is F. So such is the way they have coded that word. So similarly, we have to code book as C, P,
E,
P and
P, L.
L.
L. C, P, P and L. Understanding? Right. So we have to identify how they have coded. So coding and decoding is pretty simple. It would be simple when compared to number pattern. Identifying number pattern could be a little difficult, a little tricky, but coding and decoding would be simple. Again, coding and decoding can happen letter coding and number coding. In number coding also, they will have numbers. For numbers, they would have had a alphabetical coding, which we have to identify. Letter coding, real alphabets in a word are replaced by certain other alphabets according to a specific rule to form a code. The candidate is required to detect the common rule and answer the questions. Whereas number coding, either numerical code values are assigned to a word or alphabetical code letters are assigned to the numbers. Candidate is required to analyze the code as per the directions. Right? So it could be letter coding as well as number coding. Last part in this chapter is odd man out. So what is odd man out? There would be some relationship among, so we have 4 options given. Among 3, there will be some relationship. One would be independent of that group. So the 3 options would be belonging to one group, whereas the other one would be independent of that group. We have to identify that independent option, and that would be the odd one out. Stranger for to that particular set. So these questions are based on words, letters and numerals. So in this type of problems, we consider the defining quality of the particular things. So what is common among them? What is common among them? The defining quality among the things, we have to identify that and then get the odd one out. Sometimes it could be a little tricky to identify odd one out. 4 or 5 elements are given, out of which one does not belong to the group. You have to find out the odd one. Okay, there is nothing much to discuss here with regard to logical reasoning because there is no concept as such. Right? So we have to apply the logic and then get the answer. So better we go with answering some questions so that it will be easy. First, before going to 41 is a little tricky. We'll come to that later. What comes at last place in RUXAD? What is the last alphabet in the series?
G.
G. Why G?
Because there's 2 letters gap after each.
Yes. So if there is 2 letters gap, R, S, T, then U, V, W, X, Y, Z, A, B, C, D. So E, F, G. So G is the correct answer. So that is how we have to answer. Then if Z is equal to 52, ACT is equal to 48, what is the value of BAT? So by they giving
46.
Yeah, by they giving Z is equal to 52, Z is equal to 52. What is the hint that they are giving?
Double.
2 times of the number.
Yes, the value of every alphabet is 2 times the order where they are placed, right? So A's value will be 2 because it's the first alphabet. So A's value will be 2, B's value will be 4, C's value will be 6. So whether what we have done is correct or not, we can check that using ACT. What is A? 2. C's value is 6. T's value is
20.
40.
40.
C is the 20th, T is the 20th alphabet. So 20 into 2 is 40. So when we add up, we get 48. That is what they have given. So using the same logic, we have to calculate the value of BAT. What is the value of B?
4.
B is the second alphabet. Into 2, 4. A is the first alphabet. into 2, 2. T is the 20th alphabet into 2, 40. So when we add up, we get 46. Understanding? Yes. Yes. So similar types of problems are there in study material. We have to just solve this kind of problems so that we get hold of how we are getting this, right? So we have to just solve some problems, then it will be easy for us to manage. Okay. Then if rows is coded as 6821, chair is coded as 73456, preach is coded as 961473, what would be the code for search?
214673.
214673.
Okay, this is simple. We have to go with this alphabet. Search. Yes. What is the code for yes? 2. Right? Here also it is 2. That's the only way we have yes. Yes. Okay. Yes is 2. Then E. What is the code for E? Go with the values that I have already given. So here rows we have E, coded is 1. Preach we have E, code is 1. So E's code is 1. Then A. What is the code for A?
4.
Chair A we have. Third number 4. Preach, 4th alphabet 4. Correct? Then R. What is the code for R?
6.
6. Rows R is 6. Chair R is 6. Preach R is 6. Then C.
7.
C. First chair has C 7. Preach also has C 7. Then H.
3.
3. Because chair second alphabet, so second number is 3. Preach last alphabet, last number is 3. So 214673 is the code. 214673 is the code. Okay. So we're getting multiple questions with regard to whether we will have sufficient space to work out these things. See, in the question paper itself, they'll give some space. In mathematics and statistics, at the end, you will have some space. And also in every page of the question paper, at the end, you will have space for solving. Okay. So you can solve, no problem. You'll have sufficient space. Everyone understood this coding?
Yes, sir.
Yes.
Yes, I'm not getting some sufficient response.
Yes,
Only few
sir.
of us are responding.
Sir.
Yes. Okay. Okay. So if E is equal to 5 and read is coded at 7, what is the code for dear?
7.
Should be 7 because READ, DER, same alphabets. So it should be 7. That's all. So these are the questions from this chapter. From this.
Sir, you said there was a hard question.
Oh, that question we missed, right? Yeah, we'll come back to it. Okay, missing term of the series 11, 10, dash 27, 66.5 and 198.5. We have to identify this number. Not getting the pattern? Okay, so if you look into this, 66 and 198, it is almost 3 times. It's not exactly 3 times, it's almost 3 times. But 27 and 66 is not 3 times. It's not even 2 times. Right? It's not 2 times also, it's not 3 times also. So if you consider it might be equal to, what is 27 into 2.5?
67.5.
67.5. So it's almost equal to 2.5. right? Similarly, 11 and 10, it's almost equal to 1. What is the difference here? It's 1 lesser than these multiples. 11 into 1 minus 1. 27 into 2.5 minus 1. 66.5 into 3 minus 1. 66.5 into 3 is 199.5. Minus 1 is 198.5. So what is the pattern that we are having? Into 1 minus 1 into 1.5 minus 1 into 2 minus 1 into 2.5 minus 1 into 3 minus 1. So going with that logic, we get 10 into 1.5 minus 1, which is
14.
14. So the other one should also be the same. 14 into 2 minus 1, 27. 28 minus 1 is 27. So this is the pattern that we have. Okay, yes, this is a little tricky. I agree. It's a little tricky to get that pattern. So maximum at best in the entire paper, at the best with regard to this, there could be one such tricky question. So we need not bother about that tricky question. We'll bother about the other questions which can be answered easily. Clear with this?
Yes.
Now with regard to this, do we need to solve some extra questions with regard to this chapter? Series, number series, coding, etc. Yes, required. If it is required, yes, then we'll take a 10-minute break and then we'll solve some additional questions and then we'll move on to the next chapter.
Okay.
Yes, we'll
Okay,
come back.
sir.
We'll come back at 8:20.
Okay,
Okay,
sir.
sir.
Thank you so much.
Thank you. Hello friends, are we back?
Yes, sir.
Yes, sir.
Yes. Okay. Shall we continue? Right?
Yes,
So,
sir.
the previous week when we were traveling, okay, Pradyumna was in railway station. We were all waiting for train. Okay, Pradyumna was observing a man. He was choking. He had swallowed a coin and he was choking. Okay, so suddenly one wise man he came, and there is some technique, right? So to take out that coin. So he used that technique and quickly he took out that coin. So it was as if he was expert in that process. So pretty quick he was. So seeing that, Pradyumna was very surprised. So he asked that man, so are you a doctor? So you are so quick in extracting that. That person replied, no, I'm not a doctor. I'm from income tax department. I know how to take out money from people. Right? Okay. So we'll continue. We'll solve some problems. Logical reasoning, first chapter we were discussing, right? First chapter, we will solve some questions. Now, this is the series, number series. Find out the missing term. 2, 7, 16, 46, 67, 92. There is an increase of 5. Here there is an increase of 9. Here there is an increase of how much?
21.
21. Here there is an increase of
25.
25. So from 5 to 9 there is an increase of 4. From 21 to 25 there is an increase of 4. From 9 to 21 there is an increase of 12. Why there is an increase of 12? Is there an increase of 12? Yeah, there is an increase of 12 because we have from 16 to one more term to 46. So what they are doing, they are increasing the difference by 4. They are increasing the difference by 4 in each number. So from 2, they increase 5. Next term, they are increasing 5 plus 4, 9. So obviously, what should be the next one? Increase of
13.
increase of 13. That is 9 plus 4. Increase of 13, we will get 29. So will that match 29 and 46? There should have been increase of what? How much? 13 plus 4, 17. Correct? So 29 plus 17 is 46. So our pattern is matching. Right? So the answer is 29. Increase of 13. 16 plus 13, 29. Next one. Find out the wrong term of the series. This is simple. Not so complicated. Which is the wrong one?
$29.
Why?
Because all of them are cubes plus 1, but 29 is cube plus 2.
Yes. So this is 8 plus 1, 2 cube plus 1. This is 4 cube plus 1. This is 5 cube plus 1, 6 cube and 7 cube plus 1. Whereas 3 cube is 27. 27 plus 1 is 28. So this should have been 28, not 29. Therefore, 29 is the wrong one. That is the wrong one. Correct. Wrong term. Then missing term.
$169.
Why 169?
Cube. 13 square.
Okay, why 13 square?
Square of odd numbers.
Square of odd numbers. 1 square, 3 square, 5 square, 7 square, 9 square, 11 square. So it has to be 13 square here. Correct? So 13 square, 169. Just a second. Next. Okay, next one. Okay, find the next term of the series, alphabet. BKS, DJT, FIU, HHV.
JGW.
Okay, how are we getting this? B, K, and S is the first one, correct? Second, they are saying D and J and T. So what are they doing? First alphabet jumping 2 places. Second alphabet reverse 1 place. Third alphabet jumping 1 place. For moving forward 1 place. So going with that, D becomes F, next set, and J becomes I, 1 step backward, and T becomes U, 1 step forward. So that is FIU that they have. Then F becomes, what does F become? Next set. F becomes
H.
H. Why? Because we are jumping 2 places. First alphabet. Second alphabet, we are going 1 step back. So I will become
H.
H. And U become B, because 1 step forward, right? So that is what they have, HHV. So going with this, what would be the next set? H becomes
J.
J, 2 step forward. So J, this H becomes
G.
1 step backward, G, V becomes
W.
1 step forward, W. So JGW is the next pattern in that set. Okay. Clear? Everyone understanding? Yeah.
Yes, sir.
Right. Next, with regard to coding. Okay. Mystify is coded as so and so. How will menaces be coded?
N. Yeah.
Correct. So tell the logic. Tell the logic.
OF.
What is the logic here?
Next
Plus
letter.
Next letter. Simple, right? M is N, Y is Z. So simple next letter. So N, F, M, N, O, F, T, then
J.
J, T. Correct. So that would be the code for menaces. Appropriately, they have used 2 words, mystify and menaces, for this subject. Next, if tap is coded as SZO, how will friend be coded? What is the logic here?
Behind
Previous letter.
Previous letter. For T, they are saying previous S. A saying previous Z, right? So similarly, F, for F it would be
E.
E.
Yeah, for F it would be E. For R,
Q.
Q.
Q. Okay, Q. Yes. I,
H.
H. Correct. Then E will be D, N,
M.
M, E,
C.
C. So that would be the code. Right? Coding is simple. Coding is easy. Then in certain code, mention is written as so and so. How is present written? So what is the logic here?
M and
The first letter is the previous letter, and the others are like interchanged, like two are interchanged.
Yes. So first letter is the previous letter. Then the other 6 letters grouped into 2 each, interchanged among themselves. En would be Ne, Ti would be It, On would be No. So going with that logic, present would be represented as, coded as P, previous letter is
O.
O. Then we have
ER.
correct
ES. TN.
S and Tn. Correct. OERESTM. Then this is reverse decoding. In a certain language, carom is coded as so and so. Which word would be coded as horse? So this is the code word, horse. What is the root word? You have to find out. Logic is simple.
We have to go then
Previous.
letter.
Yeah, logic coded word is the previous letters. So this should be the previous letters. So if I have to find out the original word, what I have to do? I have to identify the next letter. Right? So what are the next letters? I,
P,
S,
S, T, F.
F. IPSTF. So that is the original word. IPSTF. Then number coding. If a certain language A is coded as 1, in a certain language A is coded as 1, B is coded as 2, and so on, how will be AICCI coded? Very simple.
19339.
Simple, right? It's just the order 19339. 19339. If Paint is coded as 74128, Excel is coded as 93596, how would you encode ancient?
Four two five one nine two eight.
That's all. See, P is 7, A is 4, I is 1, and so on. So A will be
4.
second alphabet. N is fourth one here, 2. C is third here, 5. Right? I is 1. E is 9. N is 2. And T is 8. So 4251928 is how it would be coded. In a certain code, 2 is coded as P, 3 as N, 9 as Q, and 5 as R, 4 as A, 6 as B. How is 423599 coded?
APN RQQ.
APN, 5 is R, 9 is Q. Okay, QQ, correct. APN RQQ. Simple. Next, odd one out. Odd one out is January, May, July, and November.
November.
Why?
November has 30 days and
30 days. All other months are 31 days. Correct. Then 10, 14, 16, 18, 23, 24, 26.
23.
Why 23?
Odd number.
Odd number. Right? All others are even numbers. 23 is odd. 6, 9, 15, 21, 24, 26, and 30.
26.
Why 26?
It's not a multiple.
Multiple of 3.
Multiple of 3. Correct. 1, 5, 14, 30, 51, 55, and 91.
$91.
Why?
It's a prime number.
But there are other prime numbers. Or your other prime numbers are also there, no?
I think, is it 51?
Why?
So 1 plus 5 minus 1 is 4. So 14 minus 5 is 9. So 4, 9.
Okay, you're going with the difference. 4,
Yeah.
9, and
It's all in squares.
16. Correct. So it should have been 25.
Yes.
Correct. So that is the answer. So 51 is the correct answer. So the differences are all in squares. 4, 9, and again here it's 91 minus 55 is 36. 6 square. So all are in multiple differences are in squares. So, but 51, 30 and 51 difference, and 51 and 55 difference are not in squares. Then next one, 16, 25, 36, 62, 144, 196, 225.
62.
62.
Simple. All are perfect squares except 62. That's all. So these are some of the examples. Other exercise questions you can solve. So now we got to know how the questions will be, right?
Yes, sir.
Right? Understanding, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. So with that, can I move on to the next?
Yes, sir.
Yes, sir.
Fine. Next chapter is direction test. Here the main thing is we have to understand the directions. If we know the directions, then nothing is there in this chapter. Very simple chapter. So at all times, at the top would be north, right is east. So since this is north, this should be south. Since the right side is east, this should be west. And between north and east, we have northeast. Between south and east, we'll have southeast. South and west, we will have southwest, and north and west, we'll have northwest. Okay. Now, some specific points given in the question, when they say he has gone left and again taken a left, it means he's traveling down. Right? He has taken a left and now taken a right, means he's traveling up. He's taken a right and now taken a left, means again up. He has taken a right and then again a right, means he's traveling down. He has traveled up, now taken a left, means he's traveling left. He's traveling up and then taken a right, means he's traveling right. Down left means right. Down right means left. That's reverse. Right? He's traveling down. Now he's taken a left means. For us, he's traveling right. The reverse. Right? So that this is the thing that we have to focus, that we have to keep in mind. Now, in any question with regard to directions, there will be the route that he has traveled that would be given in the question. So preferably draw that also, so that it will be easy for you to finally come to a conclusion. Okay, we'll solve some questions so that it will be easy. M is to the east of D, F is to the south of D, K is to the west of F. M is in which direction with regard to K? So just by reading the question, we'll understand nothing here. So what we have to do? We have to write it down. M is to the east of D. So if D is here, where will be M? Right or left?
Right side.
Right.
Right side of M, D. Why? Because east. East is this side. Correct? So M will be here. Then F is to the south of D. So where will be F?
Down.
Down. F will be here. Below D, south of D. K is to the west of F. West means
Left side.
left. So F is here. K will be here. Left, west of F. So now M is here. K is here. So
Northeast.
what is
North.
the
Northeast.
direction? M is in which direction? So from when to K, where is M?
Northeast.
Northeast.
So this is east. This is north. He is in the northeast. So northeast is the correct answer. Getting this?
Yes,
Yes, sir.
Yes.
Yes,
Next one. Next one is it's good. Cyclist goes 30 kilometers towards north, then turning right is missing there, goes 40 kilometers. Again, he turns to his right and goes 20 kilometers. After this, he turns to his right and goes 40 kilometers. How far is he from the starting point?
10
10
kilometers.
kilometers.
10 kilometers. So he goes north 30 kilometers, turns right, goes 40 kilometers, turns right, goes 20 kilometers, then again turns right, goes 40 kilometers. So he is there. This is 20 kilometers. So he has traveled 20 kilometers. 10 kilometers is pending. So he is 10 kilometers from the starting point. He is 10 kilometers from the starting point. Then a boy from his house first walks 20 meters in northwest direction, then 20 meters in southwest direction, then 20 meters in southeast direction. Finally, he turns towards his house. In which direction is he moving?
Northeast.
Northeast. Okay.
Northeast.
We'll see. So he first walks northwest direction. Northwest means this side. Northwest, then southwest. Southwest means this side. Then southeast, so this side. Then this is his house, so he is turning towards his house. So which side he is facing?
Northeast.
Northeast. So he is facing northeast. This is north, this is east, so in between, northeast. So northeast is the correct answer. Raju leaves his house and walks 12 kilometers towards north. He turns right and walks another 12 kilometers. He turns right, walks 12 more kilometers, and turns left to walks 5 kilometers. How far is he from his home and in which direction?
17 kilometer east.
17 or 7?
17.
17.
17?
Yes, sir.
Yes, it is 17. Walks 12 kilometers towards north, turns right, walks another 12 kilometers, turns right, walks another 12 kilometers. So he's exactly 12 kilometers towards east from his house now. Now what he is doing, he's taking a left, not right. He's taking a left. So left is, since he is coming from that side, left means this, not this side, right? So left, he is walking 5 kilometers, which means he has traveled 17 kilometers east from his house. 17 kilometers east. Next, a child goes 50 meters towards south, and then turning to his right goes 50 meters, turning towards left goes 30 meters. Again, he turns to his left and goes 50 meters. How far is he from his initial position?
30 meters.
Others?
30 meters.
So 50 meters towards south, turns to his right, then goes
Left. His left.
correct, 50 meters, then turns to his left,
30 meters.
30 meters, again turns to his
Right. Left.
left, goes
50 meters.
50 meters. So how far is he from his initial position?
30 meters.
30 meters.
30 meters.
How? He
80
has-
meters. 80.
80.
It's 80, right?
30 plus 50.
Yeah, it's 80. So 50 and this 30. So it should be 80. Right? So taking left and taking right, we have to be very careful. So it's in the opposite direction. So we have to be a little careful. So these are the 5 questions which are there in this. We'll also look into the study material. So this chapter is reasonably easy when compared to the first one. First one, we have to identify the pattern. Specifically in the number pattern, it is a little tricky, but this is easy. A man starts from a point, walks 2 kilometers towards north, turns towards his right, and again walks 2 kilometers, turns right again and walks. What is the direction now he is facing?
South.
South.
Just a second. Okay, he walks 2 kilometers north, then take a right 2 kilometers, then take a right and walks. What is the direction he's facing?
South.
Because he's coming down. Since he's traveling down, the direction he's facing is south. Understanding?
Yes, sir.
Yes, sir.
Yes. Okay. Then Ramu walks 5 kilometers starting from his house towards west, then turns right, walks 3 kilometers. Thereafter, she takes left turn and walks 2 kilometers. Further, he turns left and walks 3 kilometers. Finally, turns right and walks 3 kilometers. In what direction he is now from his house?
West.
Okay, so approach the question. See, going with that speed that I have read, obviously we'll get confused. So we have to go a little slower, read the sentences individually. So first what he is doing, walks 5 kilometers towards west. West means which direction? Which means which side?
Left.
Left.
Left, correct. So left side he is traveling 5 kilometers. Then what he is doing, turns right. So turns right, travels 3 kilometers, takes left, walks 2 kilometers, then turns left, walks 3 kilometers. Finally, he takes right turn. So right means this side.
Left side.
Left side, correct. Takes right and walks 3 kilometers. So in what direction he is from his house now? This is his house.
West.
So from his house, he is on the west side. Correct. So answer is west. Correct. Next one. Gopal started walking 2 kilometers straight from his school. Then he turned right and walked 1 kilometer. Again, he turned right and walked 1 kilometer to reach his house. If his house is southeast from his school, then in which direction did Gopal start walking from his school? So you know the destination, but from starting point, what is the direction you started?
South.
Northeast.
Southeast. Okay, you're talking the starting point. So this is school. If this is school, which direction they are saying? Southeast. So here. House is here. Correct? House is here, southeast. So what did he do? Gopal started walking 2 kilometers straight from his school, turned right and walked 1 kilometer, again turned right and walked 1 kilometer. So he started straight 2 kilometers, took a right 1 kilometer, and again took a right. So no, this is left, right? Took a right and again took a right to reach it. So what is the direction that he has started?
East.
East. So he took he went 2 kilometers, took a right 1 kilometer, again took a right 1 kilometer. So he has started from east. Clear with that? Do I need to explain that again?
No, sir.
No, sir.
Next one. A man starts from a point, walks 2 kilometers north, turns right, walks 2 kilometers, turns right again and walks. What is the direction now he is facing?
South.
Out.
Yes, 2 kilometers north, takes a right. So he's facing south. So we have to be careful with the requirement in the question. So they can ask, what is the direction that he is traveling? They can ask, what is the direction that he is facing, right? So the requirement of the question can differ. So we have to be a little careful. Janki started from her house and walked 2 kilometers towards north. Then she took a right turn and covered 1 kilometer. Then she took again a right turn and walked 2 kilometers. In what direction is she going?
South.
Yes, 2 kilometers north, take a right, 1 kilometer, again take a right. So walking down, which is south. That's all. So these are some of the questions which are there in directions. So we have to be careful while reading the question. That's all. Reading the question, taking left, taking right, etc. We have to be a little careful. Apart from that, if we are aware of the directions, then this is simple. This chapter is simple. Next chapter related to this is sitting arrangement. Right? Who is sitting next to whom, etc. Since we are online, it is difficult for us to relate. Physical classes we would have related, right? So here there could be different arrangements: linear arrangement, circular arrangement, polygon arrangement. Forget polygon. We are only learning linear and circular. Linear arrangement means sitting one beside the other. Circular arrangement is sitting in a circle, round. Okay. Now, what are we discussing here when we are discussing seating arrangements? First, when we are approaching the question, first we have to take a review of the given information, go through all the information given. Okay. Then you will get an idea of how it would be arranged. Then certain information would be definite information that Mr. X is sitting at the corner, or X is third from the corner, third from the right corner. So there is a definite information about that person. So such information, you can start with such information, definite information. Certain information would be comparative. Y is immediate right to X. Z is immediate left to X. So these are comparative information. So that should be approached next. So first we have to go with the definite data. then some comparative data, then therefore there would be some negative information also. W is not sitting next to dx. So that's a negative information that they are giving us, confirming, so that it helps us in placing the people besides each other, right? So first we have to go with the definite information given and then comparative information. What is definite information? When the place of any object or person is definitely mentioned, then we say it's a definite information. X is sitting on the right end of the bench. When place of any object is not mentioned definitely, but mentioned only in the comparison of another person, then we say comparative information. A part of definite information may consist of negative information. Negative information does not tell us anything definitely, but it gives an idea to eliminate a possibility. So W is not sitting besides X. So where we have to eliminate that possibility. So that also helps us in arranging better. So with regard to linear arrangement, we arrange persons in a line or a row, right? So what are we doing here? Identify the number of objects. What are the number of people involved there? Use pictorial method to represent the people. So draw, no problem. We will represent them. Arrange the information with relevant fact and their position and try to find out a solution. So the question might require something else. The question might say who is sitting behind before yes, who is sitting besides X, next to Y, etc. However, what we have to do is with the given information, first we have to arrange the people together so that it is easy for us to locate the required question. Answer the questions based on the arrangement made. Here, certain points that we have to focus. There are few words which we have to be paid attention. Between means sandwiched. That we know. Between means sandwiched. Immediate left is different from to the left. Okay. So here PQRST, Q is immediate left to R. Q is immediate left to R. But P is also left to R. Right. So immediate left and to left is two different terminologies. So when they say to the left, it need not be immediate left. However, if say immediate left, it has to be immediate left. Okay. So in the same example, Q, R, S and T are to the right of P. Q, R, S and T. However, Q is immediate right to P. Right. So similarly they have given us. However, in certain cases, they can be arranged in two rows. Right. In such cases, in this example itself, A is opposite to B, B is opposite to E, C is opposite to F. A is diagonally opposite to F, D is diagonally opposite to C. Okay, so if they give diagonally opposite, this is how we have to arrange. If they say opposite, this is how we have to arrange. That is linear. Second one that we have is circular. Circular arrangement in a circle. So in a circle, what we have to focus is they'll give you left and right. Okay, what is left and what is right? So we all know clockwise and anti-clockwise. What is clockwise? This is clockwise. Correct? Anti-clockwise is the other way. So if they say left, it means in the clockwise direction. So if we know A is sitting here, if they say B is left to A, then here. B is sitting left of A, then B is sitting here in the clockwise direction. Whereas right means anti-clockwise direction. If C is sitting right of A, it is here. Okay. So left means clockwise, right means anti-clockwise. That is the only thing in circular arrangement. That is one additional point that we have to focus. Left means clockwise, right means anti-clockwise. Is that clear? Yes. So that is about seating arrangements. Can we look into some questions? So what we have to focus on in the questions, first we have to look into the question entirely, identify the number of people involved there, number of people or number of students, number of object involved there, then identify whether it's a linear arrangement, circular arrangement. Going with, if it is a linear arrangement, check for definite information. First start with the definite information, then go with the next set, comparative information. Okay. Yes. I think we have it here. Yes. Okay. P, Q, R, S, T, U, and V are sitting on a wall, and all of them are facing west. S is on the immediate left of R. T is at an extreme end and has Q as his neighbor. V is between Q and U. S is sitting third from the north end. So here, what are the definite information that we have? One is it linear or circular?
Linear.
Linear.
Linear. They're sitting on a wall. So obviously they cannot sit circular. It has to be linear, right? So it is linear. And what are the definite information that we have?
S is sitting third from the north end.
S is sitting third from the north end and T is at the extreme end. We do not know which extreme end. Right? So T is S is sitting third from the north end. Now they are facing west. Facing west means they are sitting like this. Correct? They are sitting like this. So if they are sitting like this, what is north to them?
Right.
Top or bottom?
Right.
Top.
Okay. Now in our discussion, this is top. Okay. Towards their right. Correct. Towards their right is north. Towards their left is south. Correct. So from the north end, S is sitting third. So where he is sitting?
Middle.
Here. S is sitting here. Correct. Now, with regard to S, they have given us some comparative information. S is on the immediate left of R. Immediate left of R. So where will R sit?
Second position.
Above S.
Yes, above S. Correct. R is sitting here. Immediate left of R, S is sitting. Right. Then we have T is at an extreme end and Q as his neighbor. So if Q should be a neighbor of T, T cannot sit here because R is his neighbor here. So T cannot sit in this extreme. So obviously T should sit in this extreme. Right? So T is sitting in this extreme, Q is his neighbor. Is that clear? So we are done with this, we are done with this, we are done with this. Then they are saying V is between Q and U. So Q is here. Between Q and U, V is sitting. So obviously V will sit here, U will sit here. Now we are left with
P.
P. Where will P sit?
On the top.
The other extreme. Correct? P will sit at the other extreme. Clear with the arrangement?
Yes, sir.
Right?
Yes, sir.
This is how we have to approach seating arrangement problems. Okay, so sometimes similar questions can also be asked. So here we have two questions. With regard to this, we have two questions. Similarly, there can be 3 or 4 questions as well. One single question, 4 sub questions. Now, who is sitting to the left of S? Once this is done, the answering the questions is very easy. Who is sitting to the left of S?
U.
U, correct. Since they are facing west, left means here, down. So U is sitting to the left of S. Which of the following pairs are sitting at the extreme end?
TP.
T and
TP.
TP, yes. T and P. T and P is the right answer. Now, next one, independent question. 5 girls are sitting on a bench to be photographed. Seema is to the left of Rani and to the right of Bindu. Mary is to the right of Rani. Rita is between Rani and Mary. Who is sitting immediate right to Rita? Again, we have to arrange first. Is there any specific information first? Definite? No definite information, right? All are comparative information as well. Okay, Seema is to the left of Rani. So, if Rani is sitting here, Seema is to the left of Rani. Then, she is right to Bindu, right? Seema is to the right of Bindu. So, Bindu is sitting here. Mary is to the right of Rani. So, where is Mary sitting? Rani is sitting here, right of Rani, Mary is sitting. But Rita is between Rani and Mary. So in between Rani and Mary, Rita is sitting. This is how we can arrange. Who is sitting to the immediate right of Rita?
Mary.
Right, not left. So
Mary.
Mary is sitting to the immediate right. Simple. Next one. 4 ladies, ABCD, 4 gentlemen, EFGH, are sitting in a circle around a table facing each other. The following information are given. No 2 ladies or gentlemen are sitting side by side. C, who is sitting between G and E facing D. F is between D and A facing G. H is to the right of B. So we have to arrange them in a circle. Again, no specific information, but we can start with the second point. C. So let us put C here. If C is sitting here, who is sitting opposite to C?
D.
D, because C is facing D. So C is facing D, and C is sitting between whom?
G. E.
G
G and E.
G and E, sitting between G and E. Then F is between D and A. So D is here. Where will A sit? Okay, where will F sit?
Sir, F is facing G, so
Yes,
he'll be
correct.
to the right side.
Yes, F is facing G, so F should sit here. So A should sit here. Correct? Because F is between D and A. Then H is to the right of B. Now we are left with only H and B. So they have to occupy these two seats. H is sitting right of B. So in a circular arrangement, when we are talking about right, it is anti-clockwise direction. So like this. So H is sitting here, B is sitting here. H is sitting to the right of B. Correct? Right? Now, this is the arrangement. Who is the immediate neighbor of B?
G and H.
G and H are the immediate neighbor of B. Who is sitting to the left of A?
F.
F.
Yes, left means clockwise direction, right? Clockwise direction. So A's left is F. F. Is that clear?
Yes, sir.
Yes. Okay. So these are some of the questions in seating arrangements. We'll look into some more questions. Okay, is this helping you, this discussion?
Yes.
Sir.
Helping, right? Okay, fine. Okay, four children are sitting in a row. It's not in arrow. A is occupying seat next to B, but not next to C. If C is not sitting next to D, who is occupying the seat adjacent to D? A is occupying the seat next to B, but not next to C. But not next to C. So obviously, C should sit here. He cannot sit besides A. And C is not sitting next to D. So obviously, D cannot sit here. D has to sit here. So this is how they have to sit. Who is occupying seat adjacent to D?
A.
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 So A is occupying the seat adjacent to D. Okay. P, Q, R, S, T, U, V, W are sitting in a row facing north. P is fourth to the right of T. W is fourth to the left of S. R and U, which are not at the ends, are neighbors of Q and T respectively. W is next to the left of P, and P is the neighbor of Q, who are sitting at the extreme ends. Okay. P is fourth. Okay, they are facing north. So they are sitting like this, right?
Sir.
Yeah, they're facing north. So P is fourth to the right of T. So fourth to the right of T, and they have not given any other information. Okay. So if T is sitting here, P will be sitting here. Fourth to the right, 1, 2, 3, 4. Then W is fourth to the left of S. With regard to W, they are saying W is next to left of P. So obviously W should sit here. Left of S, fourth to the left of S.
Left of T.
W is fourth to the left of S.
S will come to the left of T.
No, W is sitting left of S, right? W is sitting left of S. Correct. Fourth to the left of, but left of S. He is sitting right of S as of our this one, right? So that is wrong, whatever we have done. Okay, we'll go with another approach. W is next to P and P is the neighbor of Q who are sitting at extremes. Okay, R and U are not at the ends, neighbors of Q and T. W is fourth to the left of S, P is fourth to the right of T. Right now, obviously W should be on this side. W should be on this side because left of S. So we have to keep S at the end, right end, so that W will be 1, 2, 3, 4. W will be here. Then we can keep P next to W. 1, 2, 3, 4. Who will be here? T. So if we arrange like this, P is sitting fourth right to T. W is sitting fourth left to S. Both the conditions are satisfied?
Yes, sir.
Yes, sir.
Correct. Then R and U are not at the ends. But they are neighbors of Q and T respectively. So R is the neighbor of Q. U is the neighbor of T. So obviously U will sit here. Neighbor of T. W is next to P is done. P is the neighbor of Q. So Q will sit here. And
Next
R
to
is the neighbor
QR.
of Q. R will sit here. We are left with
V.
V,
So who are sitting at the extreme ends?
T and S.
Yes.
T and S. T and S are sitting at the extreme ends. T and S. Okay. There are 5 houses P, Q, R, S, T. P is immediate right of Q. T is immediate left of R. And immediate right of P. Q is right of S. Which house is in the middle?
P is in the middle.
Yes. Okay. So P is immediate right of Q. So Q and P. T is immediate left of R and immediate right of P. So T is immediate right of P, which is immediate left of R. Then we are left with P, Q, R, S. Yes. Q is the right of S. So Q is in the right of S. So which is in middle? P. House P is in the middle. 5 friends are sitting on a bench. A is to the immediate left of B, but on the immediate right of C. D is to the immediate right of B, but on the immediate left of E, who are at the extremes.
C and E.
A is immediate left of B, okay, but on the immediate right of C. D is to the immediate right of B. So D will be here and on the immediate left of E. So E should be here. So who are at the extremes? C and E. C and E are at the extremes. Yes. Okay. So similar questions would be there. Is that fine? Clear with this chapter? Can I move on to the next chapter?
Yes, sir.
Yes, sir.
Yes.
Yes.
Last chapter of logical reasoning, our most interested chapter, blood relation. Right? So I have to understand blood relations here. So unless we understand blood relations, we cannot solve these problems, right? So here, blood relation means those persons who are related by birth rather than by marriage. So there are some relations given here. So we have to just look into these relations. Only these relations will be asked in the exams. Okay. Father's father, grandfather, father's mother, grandmother, father's brother, uncle, father's sister, aunt, then children of uncle, cousin, wife of uncle, aunt, like that. So there are various other relationships given. Focus on that relationships. We have to get the relationships right. Second one, we have to get the gender right in the questions. Okay, the grandmother, grandfather, both would be given in the options. We have to identify the gender right and then select the appropriate option. So these are the relations that they have given. If we go through these relations, that is sufficient. Okay, son's or daughter's daughter is granddaughter. So like that. So they have given us complete, full detailed relationships they have given us. We have to just focus on that. Okay. D is the daughter of E. A is the son of D. C is the brother of A, B is the sister of A, F is the brother of D. How F is related to B? Again, the approach is to draw family tree. We have to given with the given information, just go on drawing family tree, you'll get it. It's very simple.
Uncle.
Okay, so D is the daughter of E. So E is here, D is the daughter, so she is female. We'll write it. It will be easy for us later, right? A is the son of D. So A is the son. So he is male, son. C is the brother of A. If C is brother, he is also the son of D, right? So C is, since he is the brother, he is also a male. And B is the sister of A. So she is also the daughter of D, but since he is the sister, female. F is the brother of D. Brother of D means son of E. Correct? F is the brother, so he is male. Now, what are they asking? How F is related to B? So F is the
Uncle.
brother of
Right.
B's mother. So brother of mother is uncle. Uncle. Yes. So that is the answer. Introducing a boy, a girl said, he is the son of the daughter of the father of my uncle. Now, who is the boy to the girl? Break that sentence. Go start from the last. Uncle. So girl's uncle. She is the girl. Uncle. Father of my uncle. So father. Daughter of the father. Daughter. Son. So who is that boy?
Brother.
So instead of saying brother, she said son of the daughter of the father of my uncle. That's all. Next. It is given that A is the mother of B, B is the sister of C, C is the father of D. How is A related to D?
Grandmother.
Okay. A is the mother of B, so A is female. B is the sister of C, so B is also female. Correct? C is the father of D, so C is male. D. Okay. How is A related to D? Since A is a female, grandmother. And okay, in this option, we only have grandmother, so it's not confusing. But in case we have grandmother, grandfather, we have to be a little careful. Rita told Mani, the girl I met yesterday at the beach was the youngest daughter of the brother-in-law of my friend's mother. How is the girl related to Rita's friend? So they're not talking about Rita's friend. Right? So Rita's friend is
Cousin.
Rita's friend, youngest daughter of brother-in-law of my friend's mother. So friend's mother, brother-in-law of my friend's mother. So mother's brother-in-law, youngest daughter. So daughter. So mother's brother-in-law's youngest daughter. So how will she be related? Cousin. Brother-in-law means father's brother, could be, right? So it's cousin. So that girl was the cousin of Rita's friend. Next one, last one. Sanjay has 3 daughters and each daughter has a brother. How many male members are there in the family? 4.
2.
2. 4 or 2?
2.
2. See, each daughter has a brother, means there is only one brother, right? Right? There is only one brother. So that brother and Sanjay, father. So only 2 male members in the family. Answer is 2. Clear? Right?
Yes.
Yes. We'll solve some more questions. Okay, this is done. Okay, P is Q's brother, R is Q's mother, S is R's father, T is S's mother. How is P related to T? Okay, simple. These kind of questions, if they give he is his brother, sister, mother, etc., go from the beginning. Whereas if they have given in a sentence, such cases come from the last, so that it will be easy. P is Q's brother. So P and Q siblings. So P is male. R is Q's mother. So R is female. R is the mother. S is R's father. So
Great grandson, sir.
S is male. Yes. T is S's mother. Okay. Then I have to.
Yes, sir. Great.
And Q, R, S. Then T is S's mother. So female. How is P related to T? How is P related to T? P is great grandson. Great grandson. So we are talking from P's point of view, right? So great grandson of T. Then this is the same. These are all similar questions. Okay, we'll check this ones. A is the mother of B. C is the son of A. D is the brother of E. E is the daughter of B. Who is the grandmother of D? So they're asking who is the grandmother. They're not asking the relationship.
Yeah.
A.
Yes. So who is the grandmother of D? A. Why? Because A is the mother of B. C is the son of A. So B and C are siblings. D is the brother of B. But who is E? E is the daughter of B. So D and E are children of B. So D is the grandmother of D is A. Next. So these are simple questions. Next. Okay, that's all. Okay, check last one. X and Y are brothers. R is the father of Y. S is the brother of T and maternal uncle of X. What is T to R?
T is the wife. Wife.
Correct. Yes. So X and Y are brothers. R is father. S is brother of T and maternal uncle of X. So X's maternal uncle is S. He is brother of T. So obviously T is mother of X, which is wife of R. So T is wife of R. That's all. So these are some of the questions which are there. Again, in seating arrangements, directions, and blood relations, visualize, write down those relationships that they have given, write down those arrangements that they have given and directions that they have given, so that it becomes easy for you. And in case of odd man out, it is easy. Coding and decoding becomes easy. With regard to pattern identifying, alphabet, reasonably it will be easy if we know the order. But numbers, sometimes it might be a little tricky. So we have to be a little careful. Solve some more problems. So you'll be thorough with that topic as well. So that's it. It's there in logical reasoning LR. Okay. So apart from that, numbering, the number related pattern where one of the questions might be tricky, all other questions would be easy. So out of 20, we can easily score 15. No, we can easily score 15. That should be our target. Clear?
Yes, sir.
Yes. Confident of statistics and LR now?
Yes, sir.
Yes, sir.
Yes. So with this confidence, can we start with mathematics?
Yes, sir.
Yes, sir.
Yes. So we'll start with mathematics. Again, we need not worry about mathematics. Is easy. It's easy. Okay, we'll go through all the topics. I'm not skipping anything. We'll go through all the topics. We'll start with an easy topic today. We'll start with where did it go? Just a second. Yeah, we'll start with ratios and proportion. Easy topic. So we have used ratios in other topics as well, right? So what is ratio? It's comparison between two or more quantities of the same kind, right? So if we write it in A divided by B, we call it fractions. The same thing if we write A is to B, we call it ratios. So if A and B are two quantities of the same kind, then fraction is A by B. If we write the same A is to B, we call it ratios. In A is to B, here A and B are called terms of the ratio. Terms of the ratio. First term is called antecedent. Second term is called consequent. Yes, it's called consequent. So if we have ratio of 5:6, what is the antecedent? 5. Which is the consequent?
6.
6 is the consequent. Now, when we are both the certain points, properties, both the terms of the ratio can be multiplied or divided by the same number. So if we have 2:3, we can multiply the ratio by 2, 4:6, which means the same, right? Or we can divide this by 2. We again get 2:3. So whether we can divide or multiply both the terms of the ratio with the same number. It has to be multiplied or divided by the same number, right? So it has to be multiplied, divided by the same number. Usually ratios are expressed in the lowest term, simplest form. The order of the terms of the ratio is very important. If we say 2:3, it has to be 2:3. We cannot write 3:2 because ultimately the representation itself will differ then. Ratios exist only between quantities of same kind. Now, if I have 2 kgs of rice and 3 kgs of wheat, I can say 2:3. But if it is 2 kgs of rice and 200 grams of wheat, no, I cannot write 2:300. It is not the correct ratio. So these grams have to be converted into kgs, or kgs have to be converted into grams, and then we have to come up with the ratios, right? So to get ratios, it has to be of the same quantity, same quantities, same units rather. To compare two ratios, convert them into equivalents like fractions, etc. Now we have 1:3:2:3, and in other ratio we have 2.3:1.2. Now to compare whether this ratio is greater than this ratio, what we have to do? We have to convert either this to decimal or this to fraction and then compare. Convert this to decimal, this to fraction, we can compare. Questions can be asked like that. They'll give you two ratios and ask you to find out the greater ratio. Which is the greater ratio? That can be asked. Then inverse ratio. So if 2:3 is the ratio, what is its inverse ratio?
3:2.
3:2. Simple. The reverse, right? One ratio is the inverse of the other if their product is 1. So 2:3 means 2/3. 3:2 means 3/2. So if we multiply them, we should get 1. The product of the two ratios should be 1. Then we call such ratios as inverse ratio. Ratio A:B is said to be of greater inequality if A is greater than B, and of less inequality if A is less than B. Simple. If ratio is 2:3, then we call this ratio as less inequality. Why? Because first term is lesser than the second term. If the ratio is 3:2, we call it greater inequality. Why? Because first term is greater than the second term. That's all. Lesser inequality, greater inequality. If the first term is lesser than the second term, it is lesser inequality. If the first term is greater than the second term, greater inequality. The ratio compounded of the two ratios, A is to B, C is to D. So if we have two ratios, A is to B and C is to D, what is the compound ratio? Compounded ratio is multiply A and C, multiply B and D. So same terms, antecedent into antecedent, consequent into consequent. We'll get the compounded ratio. Okay, for example, 3:4 and 5:7 is 3 into 5, 15, 4 into 7, 28 is the compounded ratio. What is the compounded ratio of 2:3, 5:7 and 4:9? If we have three ratios, can we calculate compound ratio? Yes, we can still calculate compound ratio. How? By multiplying the respective antecedents and multiplying the respective consequence. So 2 into 5 into 4. 2 5s are 10. 10 4s are 40. 3 7s are 21. 21 into 9, 189. 40 into 189. A ratio compounded of itself is called duplicate ratio. So 2:3. If 2:3 gets compounded by 2:3, which is 4:9. Which is nothing but 2 square is to 3 square. That is called duplicate ratio. It is called duplicate ratio. If it gets triplied, that is cubes, 2:3, cubes of those terms, 2 cube and 3 cube, we call it triplicate ratio. If we square the terms, we call it duplicate ratio. If we calculate the cubes of the term, we call it triplicate ratio. If we calculate the square root of the terms, we call it
Subduplicate.
Subduplicate ratio, correct. And cubes of the subtriplicate of the term, we call it subtriplicate ratio. So we have a ratio. If I calculate squares, we call it duplicate. If I calculate cubes of it, we call it triplicate. If I calculate square root, we call it subduplicate. If I calculate cube root, I call it subtriplicate. Subtriplicate ratio. Then if the ratio of two similar quantities can be expressed as ratio of two integers, then we call it commensurable ratios. If they cannot be expressed in integers, incommensurable ratios. So simple. If they are in the form of integers, they are commensurable ratios. If they are not, then commensurable ratios. Next, continued ratio is the relation between magnitudes of three or more quantities of the same kind. So we have three, A, B, and C. If I say A is to B is to C, we call it continued ratio. We call it continued ratio. This is about ratios. That's all. So we have to just understand the main points with regard to this. What is duplicate? What is triplicate? Subduplicate? Subtriplicate? Questions will be mainly focused on those. Compound ratio, right? So questions will be mainly focused on those things. Next part of this chapter is proportion. What is proportion? Two ratios equaling the two ratio. Equality of two ratios is proportion. Right? Four quantities A, B, C, D are said to be in proportion if A is to B is equal to C is to D. We'll write it as A is to B as to C is to D, or A by B is equal to C by D. Multiply AD is equal to BC. Cross multiplication. So the quantities A, B, C, D are the terms of the proportion. Simple. If A is to B is the ratio, A and B are the terms of the ratio. Now we have proportion. So we have four items A, B, C, and D. So these are called terms of the proportion. These two are called extremes. These two middle two terms are called
Means.
The two A and D are called extreme. First and the fourth terms are called extremes. B and C, the middle, second and the third one are called means. When three or more numbers are so related, so that ratio of the first to second, ratio of second to third, third to fourth are all equal, the numbers are said to be in continued proportion. What is that? X is to Y, as to Y is to Z, as to Z is to W. So continued proportion, continued proportion. So when X, Y, Z, W, P, and Q are in continued proportion, in this case, they are said to be in continued proportion. If a ratio is equal to reciprocal of the other, then either of them is in inverse proportion of the other. For example, 5 by 4 is inverse of 4 by 5. right? So this is reciprocal of the other. So obviously 5 by 4 is the inverse of the 4 by 5, inverse of the other. In a ratio A:B, both quantities must be of the same kind. While in a proportion A:B is equal to C:D, all 4 quantities need not be of the same kind. A:B should be of the same kind. C:B should be of the same kind. So if A and B are in kgs, if A is in kg, B also should be in kg. Whereas C and D can be in inches also, no problem. So A and B should be in 1 units, C and B should be in other units. Because they are 2 different ratios. We are equaling those 2 ratios. If A:B is equal to C:D, then D is called the 4th proportion. If A:B is equal to C:D are in proportion, then A by B is equal to C by D, that is AD is equal to BC. Product of extremes is equal to product of means. Important property here. So AD is equal to BC. A and D are extremes. Product of extremes is equal to B into C. BC, product of means. Product of extremes is equal to product of means. This is called cross product rule. Product of extremes is equal to product of means. 3 quantities A, B, C are of the same kind, are said to be in continuous proportion if A:B is equal to B:C. So A:B, B:C are 2 ratios where B is common. So we call it as continued proportion if A:B as to B:C. In such cases, product of extreme is equal to product of means will be B square is equal to AC. B square is equal to AC. B is called the middle term, that is the mean proportion. There is only one mean in that case. And A and C are called the extremes. But here there are only 3 proportions. A is the first proportion, B is the second proportion, and C is the third proportion. There is no 4th proportion in that case. Thus, if B is the mean proportion between A and C, B square is equal to AC, B will be root of AC. So in proportion, in ratios, we have discussed about continued ratio, duplicate, subduplicate, etc. Similarly, in proportions also we have some kinds of proportions: invertendo, alternando, componendo, dividendo, etc. Right? If P is to Q is R is to S, then reverse of it. Q is to P, S is to R. We call it invertendo. We are inversing it, right? I'll explain. 1 is to 2 as to 3 is to 4. What is this invertendo proportion?
2 is to 1 is to 4 is to 3.
1
2 is to 1 as to 4 is to 3. What are we doing? Ratios, we are reversing. That's all. So this is called invertendo. What is alternando? A is to B is equal to C is to D is the original proportion. C will be brought into the first proportion. B would be sent to the second proportion. The means are interchanged. Means are interchanged. So that we call alternando. So A is to B is 1 is to 2 as to 3 is to 4. Its alternando proportion would be 1 is to
3 as to 2 is to 4.
Yes, 1 is to 3 as to 2 is to 4. This 2 and 3 will be interchanged. Middle terms will be interchanged. Then A is to B is C is to D. Its componendo will be first term would be the sum of the ratio, similar of the both the ratios. So if A is to B is the first ratio in the proportion, in its componendo proportion, the first ratio would be A plus B is to B. Second term would be the same. Similarly, third term would
plus
be
D is to D.
sum of the
C
2
plus D
proportions.
is to
C
D.
plus D is to D. Getting this?
Yes, sir.
Yes, sir.
Yes.
Yes.
Very good. Okay. So this is componendo. Then the next one, dividendo. Even though it says dividendo, we are not dividing, we are subtracting. Okay, we should not get confused here. We are subtracting, same as componendo. Instead of addition, we are subtracting here. So we have A is to B, C is to D. We will write A minus
A
B
minus D is to B. B minus D is to D.
B minus D is to D. This is called dividendo. Then componendo and dividendo. Componendo and dividendo, simple. First ratio, first term would be componendo, second term would be dividendo. Second ratio, first term would be componendo, second term would be dividendo. So in the first ratio, what is the first ratio? A is to B. So what would be its componendo?
A plus B.
A plus B. Second term would be its dividendo. What would be the dividendo?
A minus
A minus B. So second is C is to D is the ratio. What would be its component of
C plus D.
D plus D is to C minus D.
C minus D? Correct. That's all. So this is componendo and dividendo. If it is just a componendo, second term would be the original ratios terms itself. Whereas it's componendo and dividendo, first term is componendo, second term is dividendo. Then we have addendo. What are we doing here? We are adding.
Add.
We are adding. So we have A is to B as to C is to D. We'll get only one ratio now. A plus C, B plus D. A plus C is to B plus D. This is addendo. If we subtract, we call it subtrahendo. A minus C is to B minus D. That's all. These are the properties in proportion. Very important, can be asked. Okay, we have to focus on this. We have to remember this, and it's easy to remember. We should not get confused between componendo, addendo, and dividendo and subtrahendo. We should not get confused there. That's all. This is with regard to proportion. So we have discussed ratio and proportion. Small concept of indices. We'll discuss that as well. So here it is mainly talking about A to the power of 5, B to the power of 6, right? So a factor which multiplies is called the base, and the number of times it gets multiplied is called the power. So instead of calculating 2 into 2 into 2 into 2 into 2 5 times, I'll write 2 to the power of 5. Here 2 is the base, 5 is the power, right? 5 is the power or index. Any base raised to the power of 0 will always be 1. In A to the power of 0 is 1, 100 to the power of 0 is 1, 1000 to the power of 0 is also 1. Similarly, if we have root, if we have cube root of 8, we can also write this at 8 to the power of
1 by 3.
8 to the power of 1 by 3. So similarly, fifth root of 25 can be written as 25
to the power 1 by 5.
1 by 5. 25 to the power of 1 by 5. If n is a positive integer, a is a real number, a is used to denote continued product of n factors each equal to a, as shown below. A to the power of n is a into a into a up n times. Right? That is what we have discussed. So with regard to this, there are some laws that we have to remember. A to the power of n into a to the power of n will be equal to a to the power of
m plus n.
Simple. 2 to the power of 3 into 2 to the power of 2. What is 2 to the power of 3? 8.
8.
2 to the power of 2 is 4. 8 4s are 32. 32 is nothing but 2 to the power of 5. So 3 plus 2. So a to the power of m into a to the power of n is a to the power of m plus n. Similarly, a to the power of m divided by a to the power of n is a to the power of
m minus
n. So 2 to the power of 3 by 2 to the power of 2 is 2, which is 2 to the power of 3 minus 2. 2 to the power of 1. Similarly, ab to the power of n will be break open the bracket. A to the power of
A
n
power n into B power n.
B power n. That is 6 square can also be written as 2 square
into 3 square.
That's all. Right? That is what we are doing here. So 100 square can also be written as 20 square into 5 square or 10 square into 10 square. Correct? So we are just breaking open the brackets. AB to the power of n is equal to a to the power of n into b to the power of n. 5 to the power of minus 3 can also be written as 1 divided by 5 to the power of 3. Right? So a to the power of minus m can be written as 1 by a to the power of m. 1 by a to the power of m. Now, if a to the power of x is equal to a to the power of y, if base are the same, and if we are getting the equation, then the powers should be the same. Therefore, x should be equal to y. Similarly, x to the power of a is equal to y to the power of a. If powers are same, and then we are getting equation, then bases should be the same. X is equal to y. Right? These are the important points that we have to remember in indices chapter. Okay, these are the important points that we have to remember in indices. So we have discussed about ratios, proportion, and indices. Any doubts in this?
No.
No?
No, sir.
So those things, some important points that we have to remember there. We have no option there, but to remember, we have to remember it. Now we are left with logarithms in this first chapter, right? Then we'll look into some problems, which can we have one more session?
Yes, sir.
Sir.
Sure, sir.
Yes, so we'll have one more session on Thursday. So tomorrow full day you'll get for preparation. Prepare well, and Thursday first half or 3/4 of Thursday you'll get. Thursday at 6:30 we'll meet.
Okay, sir.
Yes.
Yes, we'll continue with mathematics and hopefully we'll finish on Thursday. No problem.
Yes, sir.
Okay, sir.
Thank you.
Thank you so
Thank
much,
you,
sir.
sir.
Thank you, sir.